Welcome back to the stream, everyone. Just getting things started. This one's going to be a little bit different than the last few, which have been, little snippets into a really big, complicated project. This one's going to be much more self-contained. The backstory behind this one is putting together a small hardware modification for some coworkers who are investigating a commercial smart lock, and also kind of collecting footage for a little blog post explaining the kind of hardware teardown side of it. So for this one, we'll have this August smart lock device, which is sort of a Bluetooth attached thing that you can stick on your door that lets you kind of remotely lock and unlock it using some IoT-ish security stuff that they've developed. And so we'll be taking that apart and looking to see what kinds of debug infrastructure the manufacturer might have left in there, and just checking that out to see what it looks like, because that's often interesting. As usual, we're streaming from the shop. I'm going to see if I can find my cat, who's usually pretty interesting to hang out with. Cool, welcome back to the stream, folks. Just getting started and kind of curious as to where my cat is going to want to hang out this time. He really likes that pile of cardboard, which is mostly detritus from my current effort at racking a bunch of my streaming equipment. Coming back over here, little dude. That rack is mostly empty right now, but it's going to have the equipment I'm using for this later. I suspect Tuco is going to want to sit on top of it once it's warmed up. So anyway, welcome back to the stream. So this one is going to be a little bit small relative to, I know we've been getting almost used to this process of delving into just a really enormous project, but this one will be a little bit smaller. So here I'm just going to be doing a teardown of this. It's a commercially available thing that you stick on your door, and then it lets you control it via, I guess, Apple HomeKit. So we're not going to be looking too deep into this. I just wanted to take it apart and investigate its debug capabilities just a little bit, and see if there's a JTAG port on it, and if so, attach some wires. But also just tear it down and take a look at what's inside, and along the way collect footage that I can use for a short blog post about this. So that's what we're going to be digging into today. I think we can pretty much get started. I'll try to follow the cat around to the camera as that becomes a thing. All right, we got our smart lock. Keyless home entry with your smartphone is their deal. Secure, trusted, smart access, auto unlock. Only one of those is really provable, but sure. Let's see what's actually in here. Oh yeah, Dark Samus in YouTube chat says that Gitter is not really great on mobile, at least on YouTube. Yeah, I agree. The mobile solution, I don't know how to do chat on mobile right now. Like, as far as I'm aware, the YouTube client doesn't really have chat built in either. So it only really works if you have multiple devices on you, which is not going to always be the case, of course. So yeah, I don't really know a better solution. Maybe we can come up with some way to bridge YouTube chat, but so far it's been, YouTube chat is kind of hard to keep the spam bots out of, and Gitter is kind of nice because we can have some talk in between streams when we want to. So there's a little quick start guide, some paper. It's like bolt it onto your door, download the app, set up the app, use the lock. That's deceptively simple, as they say. But yeah, and then there's a little bracket. It's got some nuts that move around, so I guess you can anchor this somewhat securely with a variety of different bolt spacings here. Oh, okay, so Ryan mentions in the Gitter chat that YouTube Mobile does have live chat now. Okay, I hadn't actually seen that in mine, but that might be a reason to at least have some kind of bridging to that chat. It's an interesting mechanical construction. And then we've got these things. Assume these are related to different sizes for the little bit inside your door that actually unlocks the deadbolt. So, plastic adapters. And then here's the thing itself, which is heavier than it seems like it would be given the plasticky aesthetic, but it's actually pretty solid, like there's some metal in there. So we've got some numbers, August Smart, and inside there's a little collar that grabs one of these inserts, it looks like. So we might as well just put one of these in so we can see it try to move, if that's useful. Looks like these are double-sided too, so each one of these has two different shaft profiles. Or maybe it's all just one. Never mind, I think I lied. I think it's all just one. So that just sticks in there, I guess. And that's a pretty solid gearbox feel. Doesn't stay in there, though. This is what looks like a speaker grill. So I expect to see some kind of buzzer under there. Hey, cat. I think I might want to get some photos with less cat in them, but at least now I know where he is. Yeah, I try to keep the YouTube chat client open, but the Gitter seem to have more options for kind of keeping community going, so that's what we have on the stream overlay. Hey, Tuco. Can I even get that over there? Aw, he's looking good. And there's nothing else in here. That, I guess, was glued down, so yeah, they don't really want you to open that part, I guess. Alright. It's so simple. So here's the actual lock. Feels pretty heavy. It's got a little overlay covering the shiny surface here. Freaking even focus on there. Can we not even focus? So the idea behind this thing, I think, is that the whole thing turns, and it acts as like a knob that you can hold on to, and it grabs the actual deadbolt inside your lock. So if you can see, this is again easier to illustrate with one of the plastic nubby bits in there. But I think the idea is that this just slides on there. And so this basically replaces the knob in your deadbolt. So it's a smart knob. I guess they didn't want to call it a smart knob. But it's not actually a lock. It's the knob for the lock. You supply the lock. And so you can turn this, and there's even a little grabby bit here with their logo on it. But then I think the way this works is it has a motor that internally lets it turn this, and it has an accelerometer so that it can sense the position. But I would expect they would design this in some kind of fail-safe way so that you can always turn it, even if the software in here dies. And there's more of that plastic. Whoa, they totally like stamped the edges. That's a nice, oh, that is satisfying. That's pretty satisfying, actually. Oh yeah, Ryan in chat says, I kind of feel better that I supplied the lock. I agree. I think it's a good idea. I think it's just, I think it's just funny that it's actually not a lock. It's just a knob. Hey Tuco, are you standing on my leg for a good reason? Because you're jumping? I get it. I get the jumping. So looking for a way in here. This seems like it is a separate metal plate, but it either probably snaps on or has screws coming from the back. Looks like the intended way in is these 3 screws on this side, so let's try that out. I might need to bring my screwdriver kit over here. Alright, screwdriver time. Also a good time to stress the importance of anti-static wrist straps and mint tea. Both are important. I don't know if I'd say equally important. I think that really depends on who you are. But for me, they're both pretty important. Oh yeah, and as Robert mentions in chat, this is about the knob being on the inside of the house. So the idea is they don't add anything to the exterior. The exterior entry is all wireless, which is itself a little dubious since I wouldn't want to be completely without a physical key if all I had was my phone. I've seen other sorts of smart lock devices where they do have an exterior portion, and then they have like an exterior keypad, and then they have a battery built in, but as a backup. I think the one I'm thinking of is a Samsung lock, which I'm kind of familiar with because a friend of mine has that on their front door, but it's always breaking. Like it has this mode where it just forgets all the code that you've saved in it. But one feature about it that's kind of nice is it has a way to stick a 9-volt battery on the front of it from outside and use that to power it up in case the internal battery dies. Of course, that also has me wondering like what kinds of possibilities are there for like glitching it through that external battery port. Hashtag. As a public service announcement, in case something like that happens in the chat and the formatting messes up, you can press the up arrow usually and edit it, unless you're on mobile. But then I don't know if there's an easy way to edit it on mobile. Let's see if this is a job for a stubby screwdriver. No. Tuco, I hear you. What do you want to? I just feel like they go all the way through. Are they going to be really long? Tuco, what do you want, little cat? Oh, he is running from nothing. Oh, that's cool. Sodium points out that there are actually some annotated internal photos of this thing. I'll have to check those out in just a sec. I mean, this is the kind of product where I can see it being really beneficial for them to try to give people confidence in the design by documenting it and making it open as much as possible. So, like, that would be a sensible thing to do. I wouldn't necessarily expect it, but if they're doing it, then, you know, good on them. That's pretty solid strategy in my book. Well, let's take a look at that document, maybe. Let's, also turn off the O-scope right now. I mean, the O-scope is off. We can turn off the overlay for it. Oh yeah, we were also getting annoyed how the YouTube chat doesn't allow people to paste links, whereas it's actually pretty nice to share links to stuff, which we can do in the Gitter chat. So, oh. Yeah, no, and I totally get if people don't want to join like yet another network, and I understand that. I mean, one way they try to make Gitter less annoying is that you can use your existing logins either for Twitter or for GitHub, which I find pretty convenient, but certainly isn't for everyone. This is nice, yeah. Usually you don't see labels like this. Usually it's just like the crappiest photo they could possibly manage to throw on the website. So 2 batteries. LED cover, front cover. This is nice. So that must be what these 3 screws are going into. That matches the layout that I'm seeing. So then it looks like this whole thing just pulls off. I might just have to pull it a little harder than I am right now, or it's possible I need to rotate it into a different position. And then there's one circuit board on the side here with an antenna, plastic ring, some gears. Yeah, usually you don't see nearly this much detail. Yeah, and then this is a flex cable going to a little doodad on the middle of the gear that has the accelerometer. That's how they actually measure the position of the shaft, because I guess that was easier than an encoder, and they can they're sure that up is always the same direction, I guess. Here are the parts that the FCC engineers care about. So yeah, this is going to be the... Oh, are there 2 radios on here? I'm not totally sure this is what we're going to see, because I've actually cheated a little bit, and I've seen a circuit board from another one of these, and I thought it had a TI chipcon, like one of the CC radios. But maybe it has 2. This looks like a Bluetooth radio. Let's see what that number actually is. This is Cypress? I thought that was a Broadcom number. I think this is... Oh. I guess there was some acquisition happening. But this is definitely Bluetooth. Yeah, I saw a version of this with a different Bluetooth chip in it, I think, if I'm not remembering correctly. This is really nice, so we should be able to use this as a guide. It's got these 2 circuit boards soldered at right angles, which is a little inconvenient. Oh, interesting. Cypress bought Broadcom's wireless division, according to Microhacks in chat. Oh yeah, Robert mentions the test pads. Yeah, so that was, let's go back there briefly. I was hoping, I mean, I was planning on discussing this a little bit later in stream, but since it's coming up, we might as well talk about it now. So, here's the circuit board we care about. Yeah, this thing. So, I was trying to find the name for this, and I'm not sure what it's called, but Robert in chat just mentioned it is not Tag Connect, which is a pretty good name for it as far as I'm concerned. If you're not familiar with Tag Connect, oops, it's going to fix my lousy typing. But yeah, this is the thing. The basic idea is it's a tiny little pogo pin jig that you can press into some stuff that you can manufacture on a circuit board for free. So it's got some large plated holes for alignment and some small test points for signal. And then there's a little plastic thing that you plug into that. So it's a neat idea. It seems like one of those things that they're trying to like way overcapitalize on what they're doing because it doesn't seem like that unique. And so this is just one of many instances I've seen where people do something pretty much just like that. But this time, I think you can actually, well, I know you can because this is what I did for Fade Candy. So on the Fade Candy board, I had this grid of test points on the back, and you can actually just get these single parts that are a grid of pogo pins. So it looks like they're using 2 of those or something equivalent, and then 2 alignment holes in the middle. But yeah, I think this is a combination of JTAG and a bunch of other I/O that they would probably want for just developer breakout. So there's probably like a little plug they make that. So I'll probably want to talk about this again later maybe, but just as a bit of a sneak preview, I think we're going to find that there are a few different ways that you might want to attach debug to this. And so we could do the kind of general purpose but kludgy thing where you epoxy a 0.1-inch header to it. You could do something that's a little bit nicer, but I don't quite have the parts in stock for, where you epoxy on a surface mount header. For this, since it has that connector thing, I could try to replicate that. I could try to make something with 3D printed plastics and pogo pins that would fit in there, or even just, it wouldn't even have to necessarily be 3D printed. Like, it could be a circuit board that matches this footprint and then has like some kind of snap post thing that fits in here, and then a grid of pogo pins. Like, there are a bunch of ways to do this. So we could try to replicate that. There are also just test points that we could try to solder things to, but that'll come up a little bit later. LEDs. Are these like Charlieplexed or something? I think these are just multiplexed into like per color. Anyway, that's neat. Good to have a bit of a sneak preview for what we're going to see later. Hey Tuco, are you down here? Really looking forward to having some help aiming the camera at the cat. So it feels like it's still hanging down there, which means maybe I just need to turn it. There's also probably documentation on how to put batteries. Oh, this presses. It's magnetic. That's how the batteries go on. Great. And it even comes with batteries, which we don't necessarily want right now, but wow. This is a little bit weird. So what do we got here? So we got batteries. We have these 3 recesses where the magnets sit. So we'll probably see additional magnets under there, unless that's just metal, but like, is this? Yeah, there are magnets under there too. But then, this is like some security stuff for Apple, but I was curious what this is. There's a separate kind of plastic here that's like maybe a bearing cover, but then if you look at the center of this, let's turn off the black square. Black squares are unnecessary in this line of inquiry. Are these tiny holes? Is this for sound or for condensation maybe? Or for like a radar motion sensor or something like that? Although I don't think this would be sufficient. These look like little laser drilled holes, but let's do a test to see if they go all the way through. Oh, these might just be for the lights. Oh, these are probably lights actually. They're probably using the same trick Apple does, where they laser drill lots of tiny holes and use that to get light through metal. Because now that I think about it, in my cheating explorations where I've seen the other board, the LEDs on that board are really bright, so they probably are expecting that there isn't much light getting through. Now I'm looking for a flashlight because I wanted to try to demo this. Maybe I'll just hold my phone screen, or my phone flashlight up to it. Where is my phone? I think I need a much brighter light. Let's turn on the flashlight. Come on. Oh, wow. How much laser etching time do they spend? Is that all? Where's that glare? Okay. Okay, it's just etched in the middle. I thought they etched this entire surface for the logo, but that was all just glare. So I think what we're looking for, there we go. From this surface, it just looks like metal, but if you light it up just right, you see that. This looks expensive. Yeah, okay, that's fun. That explains the weird texture on this side. So this is, I guess, the side they actually drilled it from. Oh no, they probably drilled it from the other side, and this is where the laser focus diverges a little bit. They probably designed it to focus just perfectly at the top surface, but not quite so much down here. Interesting. This still looks expensive. Like, this was machined and then laser drilled. That's like the kind of stuff that your founder comes to you and asks you to do as a mechanical engineer, and then you're like, are you sure? This is going to make it so much more expensive. Oh yeah, so Dean in chat is saying it is expensive. There's a reason why most startups should stay far, far away from trying to replicate what Apple does. The iPhone box costs like $14 for Apple to make. Yeah, I've been in I've been really close to that effect in startups where like you want something that fits up to consumer expectations, but then that leads to all of these things that are like unexpectedly just like really expensive, like packaging that costs like $10, or another thing is like people who really want their thing to be white and shiny and have like perfectly straight sides. Like all of that makes your injection mold tooling way more expensive than it already is. Like there are all these things that are accommodations for manufacturing that make things look the way they are, and then Apple kind of takes pride in being like, we don't need any of that stuff, we can just do it our own way, but then passing that price on to everyone. Not even just their customers, but the customers of other companies that have to follow in their footsteps. So it looks like we got 3 volts on each side. Oh, there were straps for that, but the straps were hidden. All right, and so this middle thing, does this come off easily? I'm still feeling that this is mostly dislodged, but there's another screw or something under here. It's probably just this thing. So let's see if we can gently get that sticker off. I don't quite know how stuck down to expect this to be, but oops, sorry about the hair cam. Life is easier without stickers. I wonder if they thought that putting the sticker under the label was helping in some way. A lot of people do that, but I don't know why. It's one of those things like grinding the numbers off of chips that like I guess some manufacturers think makes the product like more secure, but all it does is annoy people a little bit. Sticker. Put that on the plastic thing out of the way. So, stickers over here in case we want it later, which I don't know why we would, but if you were doing something sketchy to this lock and then reassembling it, then maybe you'd want to put the sticker back on. Oh wow, there's a little X thing. Is that actually their attempt at trying to secure this? What's going on there then? Is that just something else I could take out with tweezers? I need to use smaller tweezers probably. This is a very small, delicate sticker, which is probably not intended to come out in one piece. Yeah, this is something for the DEF CON Tamper Evident workshop, although it seems like with a tiny bit more isopropanol, it actually wouldn't be too bad. This appears to be a Tamper Evident sticker. And it's really easy to tear, and it's very sticky, but the isopropanol pretty much destroys the stickiness of the adhesive. And then it's just sitting directly on top of a flat-headed screw. At this point, I was just kind of trying to take it off in one piece for fun, but yeah, it is pretty difficult. I almost had it, but then it ripped. So, definitely a Tamper Evident sticker. But not a great one. Like, with a little bit of practice, I think I could get these off in one piece. It does look like the glue on this side just hadn't quite soaked with the alcohol enough. So, nice job, guys. You were trying, but it doesn't actually help that much. Oh yeah, Emily in chat suggests that maybe it's also a moisture sensor. I was curious about that too. I was half expecting it to kind of just completely disintegrate when the alcohol hit it, but at least that solvent doesn't seem to do much. I guess we could test it for water if I have any of the sticker handy still. Yeah, let's see if the sticker reacts to water. It's one of those times it would actually be useful to have a slide for my microscope. Let's make this significantly more in focus in just a sec. So one of my goals here is to try to put it back together with the debugging stuff mostly intact, just so that it can be like easier for my coworkers to work with and easier to ship back to them and all that kind of stuff. Since, for a little bit of context for anyone who missed it, I tried to give some context at the very beginning of the stream, but I'll try to give it a little more often also. So this is a combination of getting some footage on how to take one of these locks apart and look for JTAG for a blog post, but I'm also doing this because my coworkers at Sanrio wanted to take a look at the JTAG port, and so I'm modifying it for my coworkers to have their own explorations with later. So that part's not mine, but this part is. Here is water. This is distilled H2O. Is it just me, or is that getting redder? Yeah, maybe that is water-sensitive ink. Yeah, maybe actually that was white to begin with, and the red X showed up when I put the ISO on it. So, yeah, that might be a moisture-sensitive sticker also. They probably just copied that from Apple. Like, are they worried about people dropping their deadbolt lock in the toilet or something? That's just weird. I guess I might as well just leave that there. Bloop, bloop, bloop. What happens if I add a little bit of ISO also? Oh, it breaks the surface tension. I'm trying not to squirt the isopropanol in my tea. Oh yeah, also as Microhex mentioned in chat, how long is it going to take before this just goes off on its own somewhere humid? Yeah, I would worry about that too. Like, the whole thing just seems a little bit questionably useful. Like, I wonder how much they did it just because it seemed like a good idea during manufacture and they were already spending money out every orifice, rather than because they actually needed this to diagnose customer like recalls or customer like service issues basically. Because the reason Apple wants them is you want to make sure that you're not spending a bunch of money to keep repairing some doofus's iPhone when they just keep dropping it in liquid and then lying about it. But I just don't see that use case for this thing. That's not the camera I wanted. There we go. Okay, I think we can now actually take this apart. So, batteries in the front. I'm also just trying to... So one of the outputs for this is going to be, I'm going to basically just screen grab from this camera for a blog post for Senrio. So I want to make sure I have some good shots in there, but... I might end up editing some of this into something later, but that isn't going to be a priority right away. Ooh, nice. That's fun. So the only thing connected to this back cover is that speaker, the thing that was right behind that kind of grill there. That looks like it is glued onto the back cover, but I think we can just carefully yank it out of the board. I think these are Pico blade connectors, these little guys. There's the back cover. So that, along with its magnet friend, and these screws can just hang out over there. So I think at this point there's a large danger of just gears going everywhere if I don't handle this very carefully. So there's a gearbox under there. You can see the back side of the battery enclosure. Doesn't look like there's that much that's interesting in this part of the mechanism, but now the whole thing can rotate. So here I'm back driving the motor, I think. Or am I? Is there a clutch in there? Oh, it looks like there's a clutch. Because I was wondering how it works mechanically, because I assume they want you to be able to just turn it pretty freely when it's not powered as a failsafe, and as just a way to not have people frustrated with it constantly. So I figured they would either have to make the motor easy to back drive or have a mechanical clutch. And so I think if you look in there, you can see, oh, so here's the motor clearly. So it looks like there's a gearbox back there that the motor is attached to. And then this is the gearbox shaft, if I'm looking correctly. So this gear here is actually the output gear for the whole mechanism. This is what turns the little plastic peg that usually fits into this back panel. This also appears to be where the accelerometer is located. So I think they're using that just to sense which way is up on this shaft as kind of a crude absolute encoder. So one thing I'm looking for right now is, well, what would it take to... Well, how would you physically want to get JTAG into this if you wanted to try to debug it sort of in situ as much as possible? And how might the manufacturers have done that? How much work do I feel like going through to get that here, and how hard would it be? That kind of line of investigation. Man, they stamped their logo in there. Where's that laser? Hard to tell. Yeah, this whole thing looks like it's very difficult to keep aligned properly. Also interesting is this shaft is not centered. So the whole thing turns, and then you're actually relying on the gear chain to turn your lock still, if I'm seeing this correctly. So you aren't relying on the, well, so how does this work? So imagine this part is bolted to the wall. So you turn the exterior here, and then the gears end up turning your lock for you. And so you can actually see way back down in there, that D shaft way back there is the shaft for this motor. But if I put the insert in again, which I keep losing. So this would be, or rather, what orientation was it? Shaft is definitely toward the bottom like that. Okay, so this is roughly the orientation it's at on the wall. That is a weird location. This is the bracket. I think it's something like that, basically. That fits over the top. Anyway, so this is basically held onto by the wall, or by the door. And that's not turning the motor or the motor's gearbox at all. So these gears are all basically safety and, to some extent, security critical. Like, I don't really know what the model is for that, but this definitely seems like they wanted it to be difficult to get into from that side. And there's a mechanical stop right there. I'm not seeing where that comes from just yet, but we probably will. And also over there. So then this whole thing, can we get this ring out? That looks like it's pressed in there. This whole assembly is loose in the housing. So what can we do from the other side? And how much do I have to worry about this coming apart? A lot. The gears are just going to fall out if I let them. Which might be what we want, but let's see if there's another way, because... Oh, maybe that is the way. Also, I'm noticing some capacitors in the battery case. How about that? See that little guy behind there? I guess they were having some trouble with certain batteries, or maybe that's like a... I don't know why they would be worrying about that for like EMC issues, because this whole thing is shielded. Anyway, we might have to take out the gear train, but let's see if there's anything else on the other side that might be easier. I don't think there is. I don't think this is the way in anywhere. I think this is... We might be able to pop this out, but I think this is just a light pipe diffuser kind of thing. And we're going to find some magnets. I think all the interesting stuff is going to be on the other side. So, as annoying as it is to deal with these gears, I think they come out next. Remove the speaker and go through that hole. We already removed the speaker. That was on the back panel here. So that was the speaker. Oh, you mean for JTAG? Maybe, except part of the problem here is I think the... Oh yeah, that actually might be a really good idea. I mean, I'm not squeamish about cutting additional holes in the plastic, so I'd probably prefer to cut a hole rather than remove the speaker. But yeah, going in through the back panel definitely seems preferable to the sides, because the sides rotate and are metal, and whereas I can just use a hot knife to go in through the back anywhere I want. Looks like the orientation this thing is designed in has this board kind of flat horizontal like that. And the whole light pipe assembly is connected to that. So let's start taking these out carefully. So this gear slides freely on a small shaft here. The central gear has the accelerometer wound around it. So before I mess with that, I want to take off this flat flex so that it doesn't break. Let's try to get a better photo of that. Oh yeah, a couple of people in chat are suggesting, Jarrett in chat is suggesting that the noise might be in case you have one of those batteries that acts as a boost converter, which a lot of people like to complain about. Very silly product, and a very silly thing for people to care extraordinarily about. It's one of those things where it kind of comes full circle, and it's like, yeah, this thing is dumb, but the fact that you care so much about it being dumb is also dumb. Let's carefully pull that out. All right. So now this whole thing in the middle, I think, comes out. So that is the actual motor shaft. It has, oh, interesting. So they have one little metal insert that goes from the D shaft to a kind of, I don't even know what that's called. It's like an I-shaped drive shaft of some sort. And then that fits into the back of this little adapter. Oh, that looks like it's designed, well, no. I thought that was allowing them to rotate relative to each other, but it looks like these edges are designed to fit in the grooves there, but no, maybe it is allowed, maybe it is designed to allow them to rotate relative to each other. Maybe that's the clutch mechanism, so that this, can rotate a certain amount manually, but then the motor kind of goes in and engages with it at a certain point. Let's keep this in one piece, I think. I'm not sure how easy this is all going to be to misalign. This seems very easy to misalign. Let's put that aside. So, I don't know that I need to take that off, but I'm just curious how this is constructed. That's a solid piece. This is just cast metal. That's not like the clutch. The clutch is the interaction between this piece and the other piece. LVDR asks, how does the knob handle multiple rotations in one direction? It doesn't. It's got a mechanical stop somewhere. I haven't seen that part yet, but I could feel it. It is on one of the pieces we took off. So the mechanical stop might have actually been this clutch, actually. We might have been hitting the motor. That might have been what was going on. So yeah, maybe this piece serves both the purpose of letting the knob turn without the computer turning the motor, so that you can actuate it by hand, and preventing that from turning, entirely all the way around. Although it seems like you'd still, there must be another mechanical catch, otherwise you'd be able to rip the accelerometer off of there in software if you just actuated the motor too far. Maybe that's what this piece of plastic here is for. So is this the same kind of shaft, or is this a different shaft? Let's check that out. Two identical shafts, cool. So then this big old gear goes there. Now we're down to kind of a gearbox, which looks like something they probably would have had to make custom too. This is probably a custom gearbox, but pretty basic. Looks like a Mitsumi motor. And what are we down to now? It really looks like this interior piece gets pushed in with a press of some sort. Like this might not... Oops. That was the D thing coming off the motor. So like this might have to come off, but if this ring has to come off, then that's going to be hugely annoying. So let's see what... It's also possible more of this front assembly comes off if we take the screws out of the motor gearbox. So maybe we just hit that next. Yeah, the UI for this thing is weird. They by putting this on the inside of an exterior door, they're totally punting on the question of, well, how do you secure the outside? Because they're relying on, well, I mean, they're not totally irresponsible for that. They're not responsible for the physical security. They're only responsible for the data security of that now. And there are probably enough existing protocols for them to build on that it's probably not terrible, but you know, you would never know without taking it apart and looking. Is this screw not magnetic? Let's fix that. Hey Tuco, where are you, cat? I don't know where the cat is. It'd be nice to have him on the stream too, you know? Enough. Yeah, great. Oh, Sean is saying, I have one of those. It'd be nice to know at the end of the stream if it's staying on the door. Well, I don't think we can figure out how secure these are in just one stream. This is just one step. Just one step, and many other steps necessary to actually investigate something. But, you know, it's easy to get into just a long, long chain of steps when trying to actually get from point A to point B in reverse engineering, but I also think there's some value in trying to document just some of those individual steps, too. So where are we at here? We have wires connecting the batteries, or the battery housings to the board. This whole thing does seem designed to come out. So it does look like they press. So the thing I was talking about pressing, there's a gear ring on the outside here and a plastic ring. These are both, like the plastic ring doesn't come out without the metal ring coming out, and the metal ring looks like it required a press to put it in. Like there are no set screws that I can see. There's a little bit of red Loctite, I think. There it was. Or maybe that's just a marker. It's probably a little bit of Loctite, though. So to get these out, I think we just have to unplug the batteries, or maybe these will take some of those cables with them. Let's try to get a picture of taking this out. That's not the right tool for the job. Not entirely sure I have the right tool for that job, but I have different tools. Come on, focus. Oh, maybe it's easier to just pull this out first. I thought the wires didn't have quite that much slack. But okay. The motor is soldered to the circuit board, which is a little inconvenient. Batteries are on connectors. And then we've got this weird little shaped thing that blasts light into the light pipe and those expensively machined bits of metal. Man, that piece is keyed so it only goes in one way. So that would not have come apart from prying on the other side. Okay. Well, now it's easy to just unplug these. Let's try to keep this motor from destroying everything else. Okay, one battery out. So each of these are 3 volts, and I think it wires them in series to get 6 volts to run this 6-volt motor. Yeah. This is very similar to the motor you'd find in like a CD-ROM drive ejector, just a really little brushed DC motor. And a likely custom gearbox that fits exactly the space they needed it to fit. And there we go. On these connectors this small, the wires often seem like a little sturdier to grab by than the edges of the connector housing. But neither is especially sturdy. You have to be pretty careful. So this is effectively not interesting right now. Capacitors in there are a little interesting. I'm assuming there's not going to be much else. It looks like just a capacitor. Oops. Keep pushing this thing out too. Alright. So now we have 2 circuit boards. They are unfortunately soldered together. If I cheat a little bit, here's something that might be useful to do in the future. Take my strap out of wireless mode. So, yeah, I was like, I don't even want to deal with that, and tried straightening it. So that's a thing. And I think in some ways this one might be a little easier to JTAG, but I also wanted to see just how kind of in one piece could it stay and still be JTAG'd. But unbending the LEDs is definitely an improvement in the developer friendliness of this board. Alright. So the bottom board is just LEDs. Soldered joint between the 2. this was the connector for the accelerometer, as you can see from the label. We have an unpopulated connector right next to it. It might be an alternate sensor. I mean, it's hard to tell right away whether it's a different kind of sensor or just an alternate placement for the accelerometer, but battery, speaker. U1, that looks like an LED driver. U13, which might be something battery related given its proximity. U5. This is their some kind of debug connector. So how would that have mechanically sit? Like if we wanted to try to take some clues from how they would have been debugging this. So the LEDs go under the gearbox, basically. In fact, the LEDs go exactly under the gearbox. That is a really good match. So that is the exposed header. No, not going to focus. Okay, so this is facing toward the front of the lock, which is the inside of the door. This is facing toward the outside. I suspect that, I mean, maybe the way they would do this is, so if this fits in like that, they might have kind of a flattish thing that just kind of like snaps up against the circuit board like my finger would be and then runs out the back. That's pretty fancy. I don't know if we need to be that fancy, but we could just solder some wires and then run them out the back. Like that. And then on here, I could just like hot knife a hole in this case, like right where this bit of molding is. Is this metal? No, this is just really dense plastic. Whoa, there's a weird bit of text on here. What is lubricant? Is that somebody who makes the plastic injection molding, maybe? That's a foam piece, but that's maybe where I was thinking of cutting. I'm curious, what is lubricant? Oops, I missed a B. Oh yeah, that is actually some pretty fancy plastic. Wow, it's plastic with built-in lubrication. These guys really did not cost optimize this product, did they? Why do they need a fancy kind of plastic for this? I mean, this is mounted stationary up against your door. This edge here is maybe what they're using as a bearing surface. That is weird. Yeah, as Robert is saying in chat, this is surprisingly not cost optimized. I would have expected much more cost optimization than this. All right. So let's free this from its enclosure. Let's look briefly at this inside. I thought I saw something interesting in there. Come on, buttons. There we go. So, what are we seeing? So this metal piece is the one that's pressed in, and oh, there's a locking bump here. how did they mold that? So this outer piece is, I think, aluminum. Yeah, this outer piece is aluminum. It has a ridge manufactured into it, which holds this gear. So they press the gear in during manufacture after putting in this plastic insert. If this plastic insert breaks, you're boned. Like, that kind of sucks. Because then all the rest of this metal stuff has to be kind of destroyed if this plastic insert cracks, just in order to fix it. What is that? That squishiness, you see that? Is that holding the battery, maybe? Yeah, I think that's a pad between the... So maybe this ring is made of that same lubricant material, and they're using that as a bearing surface between the rotating part and this metal. That would make a little bit of sense. Does this press up against that too? Jeez, this thing must have been really annoying to assemble. Like, in their factory. Okay, once you get all the wires out of the way. Yeah, so this back piece and this ring, I think, are both made out of this self-lubricating plastic, so they're pressing up against this gear. That's interesting. And then the gear is how it, is driven by / drives the outer perimeter of this thing. So then that means that none of the rest of these plastics, I think, can come out without, like, unpressing that, which would probably require building a jig. So I'm not going to do that unless I absolutely need to. But I also saw something interesting on here. This looks like a metal... Oh, no, this is a plastic sticker. So you can see there's a... Oh, I can barely see it, as I say, you can see. You might see the edge right there of what looks like a little bit of plastic in a ring. I think that is a sticker, which is maybe, again, a slippery surface for the internals to slide against. So I think what they wanted is for, basically this entire thing is a smart knob. Like, the interior structure is designed to be stationary, and then this turns, but they want to make sure nothing inside is, like, dragging against the metal as it turns, so that was their solution to it. And then this gear is actually how they drive the knob. Interesting. I think that's about all we're going to learn from this piece. This is pretty straightforward. I'm just thinking, like, how do they manufacture this? Because, like, so this is injection molded and brass inserts, so that's not too unusual. I don't know if they... Like, it's nice seeing the brass inserts. A lot of manufacturers wouldn't have used brass inserts for this because they don't have to be opened and closed on a regular basis. But then this is just a weird mixture of, like, trying to kind of make it strong, but also making it completely impossible to take apart and fix. So I'm not really quite sure why they chose that route. But yeah, I can see how, like, if they were trying to make this look like an Apple product, this is a lot of the same stuff, like completely over-the-top mechanical design at the expense of maintainability and simplicity and sometimes even reliability. And this doesn't have any mechanical stop in it with that middle piece gone, which is kind of nice because I would have been more annoyed with this if I saw multiple different mechanical stops that all had to be aligned together. So having a single mechanical stop seems good. All right, so then on this piece, this is like the actual guts of it. So these three parts are not easy to take apart. The motor is soldered to the main board. The LEDs are soldered to the main board. If I'm planning on putting this back together, I want to keep that in place and just work on, if possible, this side of the board. Oh, hey, Tuco. Let's look at the other side of the board first to see if there's anything interesting on it, but then, if possible, it would be nice to ignore this. There's a flat flex connector. I wonder what that's for. wonder if that's debug, because that would be convenient. I mean, my guess is either the flat flex is debug or LEDs, but the LEDs don't seem to go anywhere else. Like, the LEDs seem to go right from this chip U1 to the LED panel here. I'm not really that concerned about the LEDs, but just for completeness, let's take a look at these driver chips over here. I think Q8 is going to be... So I think these are multiplexed. Just looking at how they're wired, it looks like we have two of, one side of the matrix. Let's actually get a... Oh, Tuco's playing with the boxes. Let me try to get the camera on that. Hey, Tuco. You're such a cat. So I don't know whether this is common anode or common cathode yet, but like whatever one is common, they have 2 of those, and the other one I think they have 8 of. Or 6 maybe? I didn't actually count them, but... Yeah, 8. So I think it's in basically an 8x2 multiplexing scheme. And so I think their 8 might be... Whoa, let's go back to the actual side we have. I think the 8 on their matrix might be U1, and the 2 might be Q8. Let's take a quick look at that in the microscope. So yeah, I'm assuming that is... Oh, LCT44. Is that a shift register? Hand cam. Just to make sure the microscope is still recording. Yeah. So we've got that. It's pretty straightforward. I wonder what that is. M618A4 U3. Something battery related, but in a little bit of a weird package. That's the part number from a couple years ago, I guess. So what do we have here? This looks kind of the same as accelerometer. I mean, it shares at least a couple of pins, but it might be a different bus. Not super concerned about that right now, since I'm assuming it's just another signal, or another sensor, sorry. This is another chip right next to the battery. C8US1465. Don't know what that is off the top of my head. So there's some stuff I don't recognize next to the battery inputs, which we could look up, but my inclination is to avoid that right now, since I don't really care about the power management on this board just yet. It might be something involving like checking battery status on both sets of batteries, or maybe they have something for switching between them or something. So this side is not super interesting. It's just power management and LED drivers. So the other side should have all the actual embedded stuff that we're interested in. And I'm already having trouble with this thing being really tall, so I'm going to have to move the microscope up and maybe clamp this a little bit. Upness, more upness. Okay, there you are, Tuco. Hey, Took. Okay, let's have the multimeter handy. I want to see if any of these, like, it looks like there might be multiple options for accessing the debugging on this thing. It also looks like this is a different revision of the board than the other one I've seen. So the other board that I was briefly looking at, which I just, I was thinking about doing the same mod for that one, but I thought it would be more instructive to start with one that hadn't already been modified for the purposes of taking like photos for the blog post and, illustrating the technique and all that. Yeah, ST does have really distinctive part markings, as Chris says. They use kind of a weird font, and they put their logo pretty big on the chip. Alright, there's a processor. STM32 L152. Huh. What's going on down here? U16 is a little bit weird. There's another crystal here. And what is this part? That looks like another radio. Or possibly the radio. This might be a different version both than the other board I had and than the FCC filing. So this looks like this would be where the Bluetooth part would go. I just don't recognize that number, so we might have to take a look at that. That's the motor driver, so that's where the motor's soldered on. A little bit of LC filtering on the motor, and this TI DRV8833. I imagine this would be an H-bridge. Yeah, L40L. Yeah, not sure what those would be either. Could be something RF related or some memory. Mag. Wonder what that would be. That looks like a sensor. I mean, this could be accelerometer and magnetometer, but I don't know why they would need that on this board that isn't supposed to be moving. Let's try to look this up, maybe. Oh, OCRA is the font, according to Emily. Nice. And then, yeah, Microhex is posting information about the CPU, so it's a Cortex M3 from ST Micro. Let's see what this number is. 2076, so 20706, I think is probably the relevant number. Ah, this is from Cypress, CYW 2706, so this might just be the new number after they got bought, or after the Bluetooth stuff from Broadcom got bought by Cypress or whatever happened. I had one. There we go. Both things. Bluetooth, system on chip. Yeah, so this also has an ARM. So this is, I think I'm finally catching up with what they're talking about in chat up there, which is that there are two processors. There's one in the Bluetooth system on chip, and then there's the STM32. So yeah, there are different explanations for why they might do that. There are like smart explanations, like they wanted to keep the protocol separate from like something for security reasons, whatever. But usually the reason people do this is because they already have some code that they want to run on the STM32, and so they just put some generic firmware in this module that pretends to be some other protocol that they can talk. So like it might do the serial emulation by itself for Bluetooth RF comm. It might be a Bluetooth LE radio and speak over the host controller interface protocol. So that's the radio. So it might be useful. So like possibly why their debug thing is so big is if they actually wanted to access the JTAG on both the radio and the main system on chip. So whereabouts would we expect to see the JTAG interface here? There's a JTAG select pin, but I don't think that's related. JTAG debug control. Connect to ground for all applications. Oh, does this just not let you update the firmware? Is that how they're playing this? Well, if this just has like canned firmware from Cypress that they don't expect people to touch, then I see why they want the STM32. So there are a couple of different kinds of Bluetooth chips. They all have processors, but sometimes they are designed as black boxes, and sometimes they're designed to run your application. And both kinds of chips are still out there. Yeah, so maybe this doesn't need like user accessible JTAG. No? I don't know, this looks like the ARM's programmable. Bluetooth baseband core. Interesting, so they've got a hardware implementation of part of the Bluetooth stack, I guess. Link controller and host controller interface. So it does look like this is designed not to be user serviceable. Yeah, firmware is in ROM. Okay. So this has an ARM, but no user serviceable parts inside, so I would not expect the JTAG on here to be interesting or broken out even. Okay, well, let's move on. So then there's the upside down STM32. Come on, microscope. Sure. So there was another version of this that just actually had like big ol' vias labeled with the JTAG points, which this version does not have. But I think maybe we just want to take advantage of the alternate options here. So that's the connector they have. There's also, where's that flat flex? Oh, that was totally on the other side of the board. All right. So maybe let's investigate this by starting out with a JTAG signal that we want to find and then looking for it on these connectors. So we can pretty easily get that from the STM32 datasheet. I always forget the button for, well, part of it is forgetting the button, part of it is that the buttons on that side of the pad actually are not especially reliable, so I keep having problems with them. Yeah, that's the right button. It just sometimes, see, I'm pushing the same button and it's going back and forth. So much yak shaving. Oh yeah, thank you. Electronoob in chat is reminding me about some folks in the YouTube chat. Yeah, so I am reading the YouTube comments theoretically. It's just I often get distracted, and it's hard for me to keep track of all the things. Let's see. About my isopropanol. Oh, so Don in chat is saying that the sticker might have been. I think what they're saying is that the sticker might have been sensitive to the isopropanol also. Mhm. Yeah, sorry about that. Alright, that's the view I wanted. Looks typical for an STM32. I'm just looking for the pinout. There we go. Almost there. So we're dealing with the LQFP48 version. And specifically, if we want this to actually match up, we would be looking at it like this. So we're going to have to look up which of these is actually JTAG, though. Can I save this? Kind of want to keep that window open. And also have another window where I can look at where the debug ports actually are. So that would be in pin descriptions. So here's where we'd have to just figure out which of these are actually used for, you know, SWD or JTAG. Got all these tasty peripherals. There's JTAG. JTAG, SWD clock, SWD IO. So we need basically these two and reset. And then we should be alright. Here's more JTAG, but we could use SWD because it's fewer wires. And either of these will give us a starting point for finding the debug interface on the connector. So let's look at the clock first. This is going to be PA14. And this tells us pin numbers too. So PA14, pin number 37. It's interesting that they use such a tiny package. So you can see that right up here. So that pin is the debug clock. Let's see if we see any other kind of neighbors up there that would be useful too. So debug data is 34, which is third on the right there. That one right there is also useful. Let's start with that though. PA14. This is SWD clock. Oh, that's cool. We're talking a little bit about maybe a YouTube to Gitter bridge, which doesn't exist yet, but seems like it might be possible since Sodium is saying in the YouTube chat that there are APIs from both sides. And I hadn't looked to see whether there was an API on the YouTube side yet, but there's definitely an API on the Gitter side. So that's what we want. I'm going to start by just checking these out. So, clock is right there. Let's maybe start a new file in DaveCAD to just grab this pin out. So that is Oh, we've even got pin numbering for us. I just noticed that. Yeah, 1, 2, up to 12. Those are numbered. Oh, I can use the grids on DaveCAD. I like it with default grids on, but not everybody likes grids. So then let's double check that, but I think this one right here should be our debug clock. Yeah. While we're here, let's grab like power and ground since those are handy. Ground should be... Where's the most convenient ground? Any of this, probably. So, definitely that one. Would have expected to see multiple grounds, actually. Yeah, that one maybe? Are these both 0 ohm? That one seems to be 0 ohm. Okay. Those two. SWD clock, and we should note pin 1, 2, pin 1, pin 2. Okay. Now SWD data. So that was serial wire debug data. Might not have that. So maybe look that up again. SWDIO is pin 34, which is third from the bottom on the right there. That should be SWDIO. Oh, that one? Cool. And then reset would be handy. Where do we have reset? That would be... Oh, Took wants to go outside. So it's PA2, PA1, PA0 wake up, ED, VSS. That should be reset. Come back, camera. No, none of these. Yeah, pin 7. Let's check that again. Hey, Took, what do you want, little guy? Oh, I might have been off at 1. I think that's actually the right one. 7. Now I've got hair in my eyes. Would they have maybe not broken out reset? That goes to a via. Just for some more context, maybe let's see if we find 3.3 volts. This should be VDD. Well, VDD analog, but I assume that would also give us 3.3 volts. That's a dead short. Pin 5 is 3v3. Dead short, pin 1 is 3v3. Oh, wait, no. 5 I thought was supposed to be ground. That's on my notes. What happened there? Was I accidentally grabbing ground also? Maybe that ground was supposed to be 3. No? That's ground. That was off by one of my notes. That would have been bad. .3v3 ground. 3v3. What do you want, little guy? Oh yeah, so people in chat are suggesting that this might be 2 separate debug pinouts, one for the Bluetooth chip and one for the MCU. I was imagining that at first, but I don't know that they would have reasons to bring out debug for the Bluetooth, and so far it doesn't look like the pinouts are the same on both sides. I think it's maybe more likely that they're treating these as one connector, but they built it out of 2 separate PCB footprints for convenience. Hey Tuco, what do you want? Hey, Tiger. Alright, so this region around here seems to... Man, they use a lot of vias in this design. But you can kind of see the flow of these traces over to the relevant pins on the microcontroller. You know, if we cared, we could start breaking that out more, but... So, okay, which signals do we care about? I think I mostly care about signals that we can get on the Blackmagic probe here, which would be SWD and maybe UART. And, in fact, one thing we might be able to do even without, like, exactly the right connector. I was hoping to just put one of these little surface mount connectors on the board, but I don't know if I'm going to wait until those come in from DigiKey. I would have traced it to a known ground on the IC. Well, I didn't have trouble identifying the ground. I just messed up my notes. Like, that wasn't the problem. I identified the ground based on the ground plane and then wrote it down wrong. But this little guy might be the right option. This is one of the Blackmagic probe accessories, and it just goes from the kind of little, kind of fine pitch box header, the 5x2, to a 0.1 inch thing that you can plug in to a header with this little right angle doodad. So this might be about the right speed for this. So I think this device also has a UART. I mean, of course it has a UART on the die, but I mean, I think it has a UART that they intended to use for debugging, since the other version of this board that I've seen that has more labeling has the TX and RX labeled. So I would expect to find at least one of the UARTs going from the CPU to this header also, but I don't know that I care that much about that right now. I think I'm mostly just going to give this SWD, which means I need clock, I need ground, and VCC. I would like reset. And then one of these is SWD IO. I think it's TDO, but I'd have to look at that. Oh, TMS, right? Because it's normally mode, but in SWD it acts as bidirectional data. So for that, for the purposes of getting into the lock without necessarily having to build a whole custom wiring harness, I'm going to try just using some jumpers that we can fit down in there. First, I guess I'll just solder this on though, because that would be nice to do. Oh, Eston to the rescue with the documentation. The other side has the decoder ring for the other signals. Cool, so we have S reset, trace SWD, that's nice. SW clock, SWDIO, nice. And the VCC doubles as a voltage reference, which is how we'll be using it in this case. Nice, let's solder this on really quick and then use that. Where are you, cat? I think he's crawling around upstairs. Use a little bit of blue tack to stick this on and then solder it. Sticking it kind of indiscriminately there, because I wanted to still have a good amount of space to grab with my vise. Beep, beep, beep. Oh, nice. So Peter also has a nice tip that if I don't connect the VREF, then I can use the target power enable to supply that, assuming I know the voltages are compatible. Well, that could be handy. There's definitely a minimalist approach and then a nicer approach where just get a couple of signals on there to see if it works, and then maybe if it works, make a nicer cable. That's probably what I'll do, since I'd be kind of surprised if this is enabled, but if it is enabled, let's make it easy to use. It's not really the right thing to use the micro soldering tip for, but it'll be fine. I'm not in the mood to switch this. If I were doing more of these, I would, because soldering 0.1 inch headers with the micro soldering tip is a little bit tedious. Especially the ground plane. Yeah, that's not the best solder joint. Oh yeah, in the microscope the board looks kind of blue. Yeah, it's a little weird. Oh, you've even got via stitching along the edges. That's cute. Very nice. So, cute little adapter. Then I think the way I want to handle this is just probably male headers that I just tack down to the appropriate points on the board. I don't think I'm going to worry about keeping the test points clean for pogo pins, although that's a thing that you might potentially worry about. A little tricky to keep this all in focus. Oh, you found the mail header in the bag too? Oh, I hadn't actually looked for the mail header, but yeah, there probably is. Yeah, there's a mail header. Yeah, no, that's cool. I think having the female header on this side works well for my business because I've got a lot more male headers I can plug into this, and I tend to epoxy them onto stuff. And so now I've got this, and I'm going to want ground. Let's have VCC. Might as well connect that, it'll be easy. What other colors do I have? I don't really want all of them to be orange. I have white and maybe yellow. Oh, I have red. Red for VCC. Orange for clock, maybe. Maybe white for I/O. And then I'm going to assume we want reset, because I kind of want reset. I don't know. Like, you can reset it through SWD, but I like having a hardware reset. Yeah, maybe I'll make black ground and green reset, because I found a black jumper. Yeah, that's what I wanted. And this is not something you want to use a whole lot, but for like a test where you don't even know if it's going to work, it's pretty much what I want. Okay, so the next step, I'm going to just tack these down on the board so we can test it, and then that'll inform what we do next. I need to go get a beer and use the restroom, so I'll be right back. Oh, Peter's not sure if the exact STM32 in here is in the firmware. Yeah, I don't know if it was either. I mean, we could use a different debug probe or add this to the Blackmagic probe if it isn't already supported. But I figured that was worth a try since I wanted to try this out. And so far, I haven't used this for much, but the little bit I have used it, it seems pretty awesome. Oh no. That's nice. Rest in peace, micro solder to ground plane. Yeah. It is dangerous. I'll be right back. Hey, Tuco, do you want dinner, actually? Is that what you want? Maybe the cat wants food on himself. He wants to eat some salmonses. I hear you, Tuco. Let's eat. I mean, I'm not hungry. You can eat. You want to eat? You're old. This. and oh no. I'm trying to see why just trying to catch up in chat a little bit. Yeah, nothing is secure if you have physical access to it. It's just, they can make it annoying for sure, but alright. So I have everything I care about working out. Let's find some places for these wires to go. So VCC. I'm going to maybe stick to the right side connector on the assumption that maybe they did try to partition this into SWD and other stuff, but oh, interesting. This power, is that connected to the power plane there, or just to this resistor? Now I'm wondering if this is like VCC or if it's like a pull-up for something, but are these fully tinted vias? Man, spared no expense, did they? So yeah, they actually went to the trouble of filling all of these vias with something and then covering over them, which is normally a step you wouldn't bother doing. Very touchy focus on this thing. Okay, so VCC. So this is ground. This is 3v3, 3.3 volt power. Ooh, is that already power plane happening? Gross. Then SWD and SW clock are next to each other. I'm just missing reset. Let's see if we can find that again. I feel like maybe I was making a mistake, because it would be really silly for them not to bring reset out to this connector. We also still haven't checked the flat flex on the other side of the board, which maybe, like, it still seems like maybe this one's in the easiest position since the other side of the board is not very accessible, but I'm kind of curious what that is still. So let's take a quick look. So on this side of the board, this side is normally right up against the gearbox, and it's kind of hard to access. So we have their LED connector, then this flat flex. So I'm just going to try to grab like one of the SWD pins and see if it's on any of those pins. Ah, that is super annoying. Let's try this. finger scope. Plant this somewhere arbitrarily first and then get the other side on. Make sure this is still beepable. It is not. That would have been annoying. There we go. One of the SWV pins on the other side. Oh, yeah. This is totally a debug connector. Let's see if reset's on here. If so, maybe I'm finding a flat flex. Where was reset supposed to come from? Pin 7 on the processor. Which is over here. Focusing the scope is not going to happen right now. I accidentally touching ground. Solder snot by test point 11 is bugging me. Well, that sounds like your problem. Oh, what do you mean? Oh, that one? Yeah, that's a good call. Conductive debris. Thank you. That's interesting. Now I'm just wondering, like, what are the use cases for these two different connectors? Like, is this something they use earlier on in design, and then they have this thing for fully assembled units? Because I can imagine if this is a later revision of the board, maybe they just never have to debug this thing when it's not assembled anymore. And so that's what they wanted. How many of these are there? That looks like 20 pin. I'm going to see what I have that might be compatible with this, because it would be really nice just to get that somewhere else, and then we can try to figure out the pin out. So here's actually what I was talking about before. So these are the little grids of pogo pins. So these solder in on the bottom, and then on the top, these are spring-loaded so they make good contact with the circuit board. These are the ones that Fade Candy uses, but I imagine there are some much smaller ones that this board would use. It's a little bit giant compared to the entire board. But yeah, imagine something like that, but much smaller. I do have a bunch of these. So you'd have these in a jig, probably also much smaller, because these would bump into each other at this pitch, but Yeah, so Peter says I would guess this is in production testing using Pogo pin header. It has the 2 central locating machine pins. So maybe that's what confused me about this. I assumed that you wouldn't need these holes if this was just a factory test jig, because it would be grabbing the board by its mounting holes. But maybe that wasn't as practical here, and yeah, it could be totally possible that this is entirely factory, like, production infrastructure, and then the unpopulated flat flex is for debugging. And that might explain why this doesn't have the reset pins. Oh, and Peter also brings up tag connect headers. Yeah, I brought those up a little earlier in stream, since I was looking for, like, I know I've seen something like this before, and I assumed that this was just a variant of it, and it turned out like tag connect is probably what I was thinking of. I thought maybe Cypress had a variant of that too, but so yeah, I think the idea behind this is you have a big plastic thing that snaps into these holes and then has Pogo pins that actually hit these. But that just didn't seem super useful with the lock fully assembled based on how much space is actually here, because it would have to be a pretty steep, like, right angle connector to actually fit in there. So maybe this is just for factory purposes. We could use it, but maybe we don't need to. So then, next question is, do I have any flat flex that is already about the right pitch and number of connectors? And then I could just solder that on there. Because clearly this is designed for a connector, but I could probably forego the connector just for prototyping and solder a flat flex on there, kind of hotbar style. That might be the right pitch. Let's see if I can get that on there straight. Yeah, this is too big, but we can just ignore the extra connectors. It's the right pitch, which is what matters. I mean, we could cut it if we really cared. So one way to solder this is to just do basically like a, what do they call this? It isn't quite a butt joint, maybe a lap joint. But that actually works really against you with the surface tension of the solder. So what I might do is turn this upside down and line them up like this and solder them like that. I think I probably will have to cut this since it's a little unwieldy to work with it so long. So let's mark and cut this to a more manageable width. And as you probably guessed, this is just something I took out of something I took apart. Like, you can buy these, but I often just recycle them. Oh yeah, Piotr has a picture of the tag connect header, so that's a lot like what I was just talking about. That's Pogo pins to actually make connection, and then some plastic alignment pins. Or maybe metal alignment pins. This one is not very long, but maybe that's fine. The other ones I have here are very different density. Oh. I also have these. Yeah, that's very different density. Okay, this one it is. I think what I want to do is just like mark this up against the board so that I am less likely to miscount and end up cutting it in the wrong place. But you could definitely imagine, like, I don't know, depending on how you wanted to approach this, you could just kind of bodge it together like I'm about to. You could try to buy the exact same connectors and cable that would fit this and then develop your own breakout board, which might be the right way to do this, but this seems like the way to do it right now, which is often what you want with prototyping. And then once you know that the thing you're trying to do is even worth doing, you can go back and do it better. You can kind of see the metal there. we want to cut it like there. I could include the mounting tabs, but I really don't think I have a reason to. So the one that I just nicked there is the one that I want to cut off. I want to cut right to the left of that. Tape this down so I can work on it a little better. How bad is that going to be? Oh yeah, it's a little easier when you're not on that tape part. It would be prudent not to go right next to a conductor, wouldn't it? Especially when you can't quite see what you're cutting. Let's just try to do a rough cut over here. Oh, this actually cuts really easily along. Oh, maybe I can go back and cut it in the right place then. Let's just like again check that that is the right place. Yeah, that's 20. I forget what I took this out of. It's like some kind of consumer electronics, I think. Oh, it's not cut copper. Definitely trying to err on the side of going left if anything goes wrong, because that's the side I'm not using. Alright, let's see how much of that needs additional work. This stuff is in some ways stronger than it looks. Alright, that's what I wanted. Custom-made flat flex is totally what this would be called. Let's try to attach this on one side. Let's maybe put a little Kapton tape down to hold this. Or actually just double-sided tape might be better. So just plain old double-sided tape. That on one side of the flat flex. I'm trying to get the light so that I can see the traces through the backing and line it up. Come on, light. All right. I'm going to try and attack this down at the edges and see how bad that is first. I think this flat flex is not designed for high temperatures, so I'm going to have to be quick. That is shorted, but we'll hold it for a sec while I do a couple more on the left side. Just solder it over the edge of the flat flex. Why not put the flat flex the other way around and bridge it over to the pins? I've tried that before, and it seems like surface tension just kind of wants to pull everything away. I'm watching the color change in the plastic here to see when the metal heats up in the trace. Also need to make really sure this is fully pressed down, but I think it is. Just be careful to tack one in the middle next, maybe. That seems nice. Let's just do some more of this. I'm like, it seems nice, and every one of you is like screaming, what are you doing to that terrible flat flex? This is how I attach the camera in my other mill. And I'm planning on testing this. That's a grubby swab. Let's use a fresh swab. Oh, how visible is the color change on flat flex without the scope, Sean asks. I don't know, I can't see it without the scope. Pretty visible. Looks about the same without the scope, just smaller. Alright, I'm going to check for continuity and shorts really quick. So, the other side, I want to put it down on something that I can poke the meter with. Maybe just a little slab of perf board. I haven't quite thought ahead to what I'm doing with the other end of this cable yet, because I think I don't know if I have connectors that mate with it, so I might just have to tap individual signals off of it. But this is less annoying, I think, than dealing with the connector on the board, since it at least gets all the signals away first. So first, I'm going to do this thing that I usually do that simultaneously checks for connections and for shorts across neighbors. So like those are already shorted, but we can see if that's intentional. So what I was going to do is start with one on this end, and then one on the other end, and then move them in kind of a stepping pattern. So like if you imagine that, sorry, where am I? If you imagine that this is here, but this is actually on the other side, I would do something like that. So in this case, you can see that the first two are actually shorted. But what this does is for every single test you do, it gives you both a positive and a negative. So you can tell that your meter's working, you have good connection, but they aren't shorted to each other. They're only connected through. So let's try doing this for real. First, let's look at those left two, since I think we might have already found a short. Those don't look like they're supposed to be shorted, so let's just add a little more flux and heat and see if that clears up. I think that'll do. Let's check it again. Still shorted. I'd like to know where these traces over here are headed, so I'm just going to scrape off the solder mask. There are a lot of ways to get this off. I like kind of very gently abrading it with the end of a knife tip. I think acetone makes it dissolve much faster, so like a little abrasive swab of something with acetone on it will also help with getting access to traces. And then if you make conductive debris, you probably want to wash it off. Slurp. Juicy copper. Oh, that is the next one. Maybe this is intentionally shorted. Oh, or maybe I fixed the short. Oh, or not. I mean, I could go back in the video and look at what that board was like and see if those were intentionally shorted. So it looks like this goes to the third pin, and we're seeing this one go to the first two. But doubling up like that would only make sense if it was going to be high current or something, so if that was like ground. But I don't think they would have a trace like that for ground. Maybe that is ground. Maybe I shorted something to ground. Or maybe that's just how ground works. I could check what this via is on the other side. I think that's a ground plane via. I don't know why they didn't put it closer. Huh. Oh, helpful. Thank you. So there is a via right there. Okay, so those are definitely separate signals. Thank you. That is helpful. So I probably do still have a short. Let's just get the iron up under there with some flux and try to lift it away. go. I think that's exposing the problem a little. Yeah, I think Peter's right. This method is certainly harder to fix shorts with. I just hadn't had luck with the other method sticking at all, but maybe it's time to try that other method again next time I do this. Now I'm looking for a little scrap of desoldering braid that I had on this table somewhere. There it is. Anyway, you can see I think that's the trace kind of lifting up. Yeah. Let's take some of the solder out and then put the trace back where it's supposed to be. Is that a booger of something conductive sitting on the tip? I think a little bit of solder to add heat conduction sometimes helps. Get rid of that booger. Yeah, so as D.A. Beckham says, pin 2 is going to the trace, pin 1 is going to a via. Cool. That seems to match what we're seeing from the photo. Come on, just stay there. Okay, let's see if that did it. That was a little messy. Nope. Oh, I see it. I just need more flux, I think. I can clear that up. That seems better. Yeah, I think I just had a solder booger in between those two. I was going to say it looks good. It really doesn't, but I think it'll be fine. Let's go back to doing the test. I can move this end a little bit at a time. that another short, or is that intentional? Jeez. I think this also might just be, it's really hard to see the left one when I'm trying to probe. Don't breathe this. Actually, I didn't get as much of the burning plastic smell as I would have expected. I don't think there was just that much of it by volume. I don't know if this is going to turn out to be worth it without 2 microscopes. It's a little hard to reliably position the left one without the microscope. Is that a misconnection? Anyway, I don't know how much I feel like actually testing this too much, because I only really care about a couple of pins, but I don't want it to break anything by shorting out unintentional stuff. Hello? There it is. Is that a short? Or is that just me putting the probe in between 2 pins? Yeah, no, that looks like a hack. Yeah, basically. Here I am thinking, why do I ever try to make anything nice? It's just going to be terrible. Okay, let's go back to looking for individual signals. So, which one of these is pin 1? assume that side with the double line is pin 1, so we have 20 pins. It's 2 rows of 10. Okay, let's position these so we can get to this connector and the STM32 at the same time, and then try to map out the interesting stuff on here. I'll try to put a dot at pin 1 on this connector. Okay, so now theoretically that can go back with the motor kind of in that space that we were just in. So let's save that. Now let's just attach here. I might need like an actual vise and not a stick vise for this. That looks like about what I want. Just want to keep that nearby so that I can see both of them around the same scale. Okay. So just to grab some interesting stuff on here, maybe we'll start with ground. Do I have any common grounds here? I have the ones that I mapped out on this connector already. Look here. And 2 is ground. More. That makes sense. That's the via we saw really close. I think the last one's ground also. I'm going to put a question mark at that, by that one isn't quite as sure. That might be a short, but it probably isn't. VCC. Turn on the little multimeter. think that's pin 9. Let me just double check that because VCC is pretty important. Yeah, pin 9 is 3.3. How about reset? Are we going to find reset on here at long last? That was pin 7 again. Is this the wrong reset pin? Because I'm not seeing this broken out. I was looking at N reset on pin 7. Seems like the only reset that we have. Yeah, that seems unlikely to be anything else. Am I just not getting a good connection to this, or are they really not using reset? I wonder if there's a series resistor or something that's preventing, you know, or like just some circuitry in between here. It's going to a via. Yeah, that goes to a via. This one. It's a little hard to tell, but maybe one of these is like a reset supervisor circuit or something, or maybe it's that test point. Let's see which of these, if any, actually corresponds with the reset. Oh, is it that? Maybe it doesn't go up there. This is where it would be useful to have scans of both sides of the board and to combine them. Assuming this stuff is all battery related, but well, it's easier to hold this between two pins, so maybe I'll grab reset and something else. I'm not seeing that on any of these chips still. It might be they just don't use reset. Alright, well, we can live without reset. So then, we just look for the rest of these that we wanted. 53 ground, SWD, IO, and clock. That is SWD clock. pin 5. And SWD data. Pin 8. Is that really 8? Let me just check this numbering again. Yeah, that's 8. And so next one is 9, actually, VCC. Yes, okay. Written SWDIO off by 1. Alright, well, this is not amazing, but let's try just continuing on. I think to break out the things that I want, I might just tape this to a little circuit board or something. I guess if I'm going to tape it to a little circuit board route, I can just put a mail header on that little circuit board. Yes, you want N reset. I mean the T reset pin. The reset will be... Yeah, so N reset is the one that I'm seeing, which I think is the system level reset. If there is another reset, which is just for the debug port, I had not looked at it yet. This has like built-in brownout reset. Yeah, N reset pin is definitely what we want. Well, okay, maybe let's spend a little more time looking at where N reset goes. It's tempting just to like drill or something through that via, if it wasn't plugged, if it wasn't like fully tinted, sort of like plugged through the epoxy, it's tempting to like thread a fine wire through it at least. Let's see if I can see the outline of the NRF from the other side if I shine some bright light. Just also getting the flat cable out of the way a little bit. No, I think the reset might actually be going to U3. I think this might be a reset management chip. I think it might be that one that's pin 3 of U3, but let's find out. This is really hard to get to on the other side. It's tempting to solder a temporary wire onto pin 7 just so I can poke around with it. I think that might be what I do. Like, I know I could just use this as my reset, but I'm also kind of concerned with finding the pinout at this point. I know I don't have to be, but it seems useful. Just going to use a little bit of 30 gauge wire, which might be a little easier to deal with here. wants more flux. Also that thing where you just notice like way after the fact that you were holding the hot part of the soldering iron. That will be enough to see where that goes. Because you think if they were going to have their own reset controller circuit and not bring reset directly out to the debug header, that there would at least be some proxy for reset, like some other signal that you could use to reset it with. No. Nice to know which of these vias I'm even looking at. I think it's one of these in the ground plane there, which is not really helpful. So probably going to an internal layer. Well, maybe we'll keep this wire. Sorry. Like, where would that be going? Does it have anything to do with this chip? I mean, there's nothing physically close about it. I assumed this was just something battery related, but let's just check these pins. I mean, with this trace going off into an internal layer, there are a lot of places it could end up. Yeah, not so much. And let's double check none of these are really supposed to be reset. Yeah. Let's move this actually wrapped around the end a little bit. It's not looking at anything over there. tempted to just scrape off all these vias just to see which one it is. Not that that's super helpful. But like, unless it's one of these, maybe? Can't quite tell which of these it is, so I'm just going to give myself a bunch. Most of these don't do me any good, if that's what it is. There we go. Anywhere else? Does it just like hop over somewhere? Where would it go from up here? Somewhere over here, maybe? Conductive debris. That's annoying. What could they be doing with reset? Okay, so maybe at this point I will cheat and bring out the other board, because the other board actually does have reset labeled on it. I'm curious if they're doing anything strange there. Whoops, I already just broke off my reset wire. Here's the other one that I mean, I haven't really done much with this one either, but it is a different board. Yeah, so this one uses a different radio. See that? Isn't that weird? Same motor driver. It's got some, what is that? LM4891. Looks like something power managery. And here's the fully labeled JTAG and serial. Maybe this is a good opportunity to cross-check this connector. Maybe they use the same pinout. I mean, this kind of breaks my narrative if I'm doing a blog post that's just about the new version and not this version, but for my curiosity, it would be nice to know, assuming this doesn't involve cheating too much. Oh, Roy says in chat, I can almost see the trace in the next layer into the scope. Yeah, probably. Ground, where was my ground? I think this was my ground. Turn on, little thing. Okay, ground is good. That one is not ground. Interesting. That was ground before. Yeah, it's definitely a signal going to the processor. And over here to the radio. And there's our reset. Is that actually connected to pin 7 now? Yes. Is it? Oh, maybe not. It's near pin 7. So this is the reset point that's labeled. This trace is actually the reset from the micro. This is a resistor. Is this tied to the reset on the radio, maybe? Yes. So the micro and the radio reset tied at this point, which also goes over here. Let's label that. Oh! That's the one that I have labeled as ground. So maybe they did take off reset as a cost-saving measure? Why would they do that? Maybe they just didn't have the space to route it, but that is really weird. And also this is separate from the labeled reset here, so I want to figure out where that goes. That goes there. Is this like a diode or something in there? It says R for resistor, and that's not connected. Measure the resistance in circuit, which is not reliable, but might give me something. In circuit, that's 2 kilo ohms. So that's probably a pull-up. This is the actual reset. So where does this go? I think it's that one. Resistor. Five kilo ohms. For any of these, power. Okay, so this is the reset that we have labeled as a presumably external interface. Does this go to any of these? We have a 5K resistor, which I assume is a pull-up. And it's not going to any of those. No. Oh. I had that in resistance mode. That's why you always need control tests. There are a million ways to screw this up. Ah. So, the one that was ground on the other revision here is the actual N reset signal. But then we've got this thing on the top left on that pin 12, which is labeled RST. So that might be instructive to look at on both this and the other board. So yeah, RST and this thing, which goes there. Check to make sure I'm actually getting the right signals from side to side of the board. Okay, that's the reset on this side. So yeah, R50, is that also going to this via? Yes. So are we going to see that going over to this logic chip maybe? Oh. There is sometimes a diode over here. This is looking like they just built their own little logic circuit to handle reset control. Is it just a diode? Is there just a diode on the other side or something? Is this S reset? No. I thought that might have just been as simple as a diode for reset, but maybe not quite. There's this side again. Oof, I need the microscope to be much more up. It's so much smaller without the microscope. Oh, this is really hard to find which goes where. Oh, is this a reset control chip? Where is the other side of this via? It's around here somewhere. Is it under the chip? I'm just looking for this. So the signal I have the other probe on. Oh, there it is. That's not useful. That's also not what I'm looking for. Maybe I don't have this on the right signal. So that I thought was the reset that is marked as reset on this board, which maybe I should just be getting from the really obvious thing that says reset really in big letters. So yeah, there's a place to get this on this board too. This one. I just want to know where this goes. So I traced that one to this thing way on the other side, which then goes. What a mess. Well, I don't know. I'm not super a fan of reverse engineering their entire reset control circuit. I'm going to see if this signal on the little pogo pin jig that matches what they had labeled as reset actually goes to somewhere reset related on the new version. So that would be this one, pin 1, should be reset related. Is that a reset control chip? Well, so this is really hard to probe right now, so I think the first step I want to do is try to see if that pin that I think might be reset is broken out to the flat flex, which is just generally easier to get to. If it is, then I'm going to see if it's actually reset. So this is our maybe reset over here. It is broken out. Looks like pin 7. Let's double check that. 7. So this might be reset. Let's see if it is. So where was that candidate chip that we thought might be a reset controller? I think that was on the other side of the board. This might make a nice little post about like reverse engineering enough of the original manufacturer's debug infrastructure in order to make something convenient for yourself. Peter is saying in chat that it might be a Schmidt trigger circuit for some strange reason. Although, yeah, part of what's confusing me too is the STM32 seems to have some good reset functionality built in, like it has its own brownout reset circuit. So, don't know. Oh, yeah, and Dr. Tune is pointing out in chat that there was already a DEF CON talk on this lock, which, yeah, I don't remember the specific details of what they revealed in that talk, but I'm sure I'm not the first one to research this, and I think I watched that talk, although I don't remember the details off the top of my head. Let's see. Yeah, so I think we were going to look at this, this chip over here. Oh, microscope focus. I just need to put this in a vise. And board again. Finally, a place for me to stick this board. So, pin 7. Right, maybe I check this one. Maybe I'm getting little tiny chips confused with each other. Let's just check anything that might be a reset control circuit. Maybe I was better off on the other side of the board. There's really very little on this side of the board to begin with. And Honestly, on the other side, it's actually a little easier to get the signal from the other connector than from here. Maybe we'll try the holding it up to the light trick. Oh, that's sounding familiar. So Sodium is saying that, as far as they remember, the DEF CON thing was that guest accounts can enroll new keys and then use those keys even after their access has been revoked. Which sounds annoying, but like maybe the kind of use case that only matters if these devices get popular. Well, let's switch back to the tall vise. In fact, tall vise plus microscope hasn't really been a thing yet. Can I make that happen? Something like that, maybe. No. It's a little bit of a weird angle, but sure. So there's the Bluetooth, and there's some little mystery chips that we haven't investigated yet. I'm kind of curious about those. I mean, there's so many rabbit holes you could go into with reverse engineering this, and I'm more interested in trying out the debug interface than just looking at these chips, but, you know, they're chips. They're interesting, right? Just getting the microscope a little bit focused, and then I can try probing around some more. So reset this one. Where are we? So is it going to be any of the stuff down here? Any of these signals with resistors? I wouldn't expect it to be any of those, but you never know. They've definitely had an EE busy on this board between revisions. Lots of little changes and some big ones. Can't test everything this way, but test a lot of it. There's some really little parts though, like, oh, can I get this one on the screen? Like, what is that even? $6CS? Like, you think that's something reset related? Is that like a chip or a diode? Oh, it says Q1 just under the jaws there. Probably something related to power management. mean, there are two approaches to figuring out if this is actually reset. There's tracing it out in the circuit, and there's just trying it. Probably do a little more tracing it out, but I'm getting close to getting annoyed to just try this out and see if we can reset it. Because at this point, it might just be going to something underneath one of these BGA parts. I don't know why they use so much BGA in this design. Like, it really does not seem like it needs BGA. And, like, there's just a bunch of random, just super tiny BGA parts around here. Like, that transistor, and, yeah, U8, whatever that is. So, but then, like, the processor is not in a tiny package. I guess if they were going to do BGA process for the Bluetooth chip anyway, they, you know, it doesn't matter that much, but that is extra cost. Yeah, let's just try it. I already have this other board wired up with flying power wires coming out of it, so maybe we try that first. So this wants 6 volts. Let's turn that on. So that's what it does when it boots up. It flashes super bright, like that. Let's see what the voltage is on that reset net, or the net that we think is reset. So, is that servo AF? I think we are servo AF. Let's also not set that directly on top of my notes. My DaveCAD window is getting covered up. Alright, so reset should be this one. 3.3 volts. 3.3 volts is 3.3 volts, and the snozberries taste like etc. This one also has N reset broken out, so that one's 3.3 volts. So, man, it might even be nice to like be watching N reset while we pulse the other one, but let's just try the simple thing first. And I'm going to use this meter in current mode to pulse the N reset low. So let's turn the current limiting down enough that even if this is doing something terrible, it won't blow the fuse in my meter. So limiting is like 1/4 amp right now. And I want DC current, ground, and so, okay, the power supply is on. It's drawing pretty much no current. It's in sleep mode. I'm going to try pulsing what I think is reset. Oh, let's first measure the voltage, actually, now that it's gone fully to sleep, and make sure we still have 3.3 volts. So the current meter on the power supply is showing 0. If I measure voltage, first at the 3.3 volt net, I get 3.3. Reset, I get 3.295. So, all right, that's checking out. So that still has power even in deep sleep. Because it might have some way of going to sleep and turning off its 3.3 volt supply, but that doesn't seem to be what's going on currently. All right, so current mode. So we should see, what I expect is I put this on reset, we don't see much current, if any. Then I take it off, we still don't see much current, if any, and it flashes shortly after, if we're successfully resetting it. Okay, so 0.09 milliamps, sounds like we're fighting a pull-up resistor. And then I let off of that, and it resets. So I think we found it. Yeah, I don't know what that's connected to, but it's acting like reset. So I think we can get to that same signal on the flat flex on the newer model board, and we'll be good. So we've got, so far, this is the Pogo debug thing. The older model has N reset here, the newer model has ground there. Then the rest of these have been the same so far. So SWD, debug, reset, which is the input to that reset circuit, ground, and 3.3 for real. A tiling window manager. I used to use one of those, actually, which might seem to disprove Chris's assertion that once you use one, you can't go back. Yeah, so Max is saying, as far as getting the firmware from an STM32, I had success just going straight to the chip for N reset. Yeah, I'm sure that would work. I think part of the reason for the diversion is that I wanted to develop a pinout for that flat flex so that we could use that in the future. Since my ultimate goal is not necessarily just to break this out, but to give my coworkers a process for breaking this out and also document some things that you might like to make this an interesting story also. So I think it's more interesting trying to find the original debug features and to figure out how to use those than to just always ignore them. Ouch. So this one, I think we want back on this device. So what do we need here? Actually, I think we can just start attaching this to a header on the other end. Get this ready to actually debug. So I wanted to use one of these little 6-pin jobbies that came with the Blackmagic probe. So that would plug in like this. This is a standard 2x5 JTAG, which I would be tempted to make an adapter directly to this flat flex, but for now this will be a good proxy. Especially since we don't even know if this will work yet. And then find a little piece of prototyping board of some sort. Let's use some of these. Then I'm going to cut this again. I think I only really want about that much of it. And there's a lot of different ways to do that. I'm going to use some big shears, basically. Giant shears. There. Let's cut this in half. All right, that'll do. All right. And we could choose to put the flex on either side of this, I guess. It's maybe a little easier if we do it on this side where the labels are. And this is also still a little too long. I mean, I guess we could do it this way. I guess I should assume that I'm probably going to maybe want to break out additional pins from this. So let's tape it down. Knife. Something like that. And tape the flat flex there and then grab the signals I want. Zero ergonomics. Least ergonomic microscope arm. That sure is purple. And it's kind of bluish too. I guess it depends on what screen I look at it on. Okay. There's a thing. So what do we need here? Ground, clock, reset, power, data, you know, that stuff. There's probably I mean, I imagine there's a serial port on here too. I don't care about the serial port yet, but that seems like something I'll want to break out later, potentially. So maybe I'll start by just tinning the ones that I want to use. And then I can put down some magnet wire. So 2. Man, that plastic really does not like heat. This might hold up better if I put another piece of Kapton tape right at the end. Anybody who hasn't used Kapton tape before should definitely try it. It's really fun. It's basically adhesive tape that is also really heat resistant. Okay, something like that is a little better. So that's sufficiently tinned. 2, 5. Six, 7. That'll need a little cleanup. 9, 10. Not 11. Not 11, I said. Oh man, I feel it's so sad every time I try to do braid with the micro soldering tip because it's really not the right tool. Let's try a small piece of braid at least. Thought I had a small, there it is. Yeah, okay, so that's fine. 8, 9, and then the last one. Alright, magnet wire. I might use my stash of already tinned and cut chunks of magnet wire over here. Alright, so this is ground. Thanks, depth. Two, and skip 3, 4, then we want 5. Depth perception fail. It is actually really nice having a 3D view on the microscope. I just use this one when I'm streaming, which is most of the time these days. It's a little gross. I might need to check that one, but it seems barely fine. Skip 6, then 7 is reset. That Kapton was also a good idea to prevent short circuits, I think. I'll put another piece over it once I've got all the wires I want on this in this particular session down. Okay, skip 1 and then do 2. And then I think that's all I need. The last one I think is ground, but I'm not even that sure of it, so I'm not going to bother connecting. not holding that like 4 inches away from the joint. Those two are maybe the sketchiest so far, but I think it's all right. So that is ground, SW clock, reset, SWDIO, and 3.3 volts. Give it another quick test here, especially the ones that look really bad. Would help if that was in the right mode. Where is the cat? We have been so catless on this stream. Can't tell if he's upstairs or outside or what today. Okay, that seems fine so far. Now let's bring the other ends out. These are actually pretty long, so I think I'm going to trim them and retin them. Oh, somebody is saying in chat, I can't tell because of how far it scrolled off, but somebody is saying it's easier to put it in a good connector and then break it out. I completely agree. That's just not the parts I have right now. I mean, and a lot of this just turns into like, well, how many cycles back and forth to the store do you want to make in order to make this project work? And right now I'm just inclined to see how far I can get with what I've got, but if you're in the ordering parts for this thing mindset, then definitely like get a board and some connectors and make it easier for yourself. And in fact, making the board wouldn't even be that bad because I could probably mill it here. It's mostly just lack of having all the right flat panel connectors and everything. But that's like one of the things to look at when you're in the reverse engineering process is like, well, if you don't mind waiting around for parts, but you just don't want to spend that much time actually working on it, then you can certainly spread the project out over more sessions and then end up probably spending less time just by ordering more of the parts. Come on. I don't know if I can put out enough heat to like really tin this super well, but that's enough. Drossy. Yeah, you get that first little bit of coverage all right. The very tip of the wire heats up pretty quickly. Okay, so ground. So, pin 2, we are headed over here. And SW clock. Reset. SWDIO. Left. Is that 333? Yeah. This is VREF. That time I was looking directly at it, you could probably tell. Beautiful adapter. Oh yeah. Okay, let's just make sure we don't have any like egregious shorts on 3v3, and then we'll try to gently power this up. That looks fine. Oh yeah, so Sean says on stream, the microscope view of solder is super useful for trying to understand how soldering kind of works. I agree, that's actually a big part of why I like to include it on the stream, because, like, to me, when I'm soldering, the things that are important are all kind of, I don't know, I feel like my focus, like the way I just have attention on it, kind of ends up magnifying what I'm doing a lot, even if I'm not using optical magnification. Because the things that actually matter tend to happen at a pretty small scale, so I like showing it that way. Even if it's stuff that I wouldn't normally do under the microscope, I like showing it really close up on video. All right, actually, just to protect this a little bit, I'm going to put another layer of Kapton tape over, but I suspect I'll have to take that off if I want to do any more soldering. Oops. Stick that on the back. So, pretty hackish, mostly just to see how well this works and see how well it's worth making something better. But I think that's what was intended as the debug connector, probably. And I wouldn't be surprised if that was maybe originally a debug connector and then turned into factory infrastructure, and then they had to leave it as factory infrastructure, but then they wanted a nicer debug cable, so they added this. That's maybe what was going on. I don't know. So this goes together like that. And that's our new debug interface. Oh, with its bit of putty under there that I was holding the connector down with while I was soldering it. Come on, focuser. All right, great. So I think maybe now the thing to do is to kind of sort of put the lock back together. It's tempting to power it. I mean, I definitely want to power it off the bench supply. I'm just looking at how to accomplish that. I need to check to... Man, they made everything fancier than necessary in here. So like in the battery compartment, it's pretty common to do the thing where you put the two batteries in different orientations. So then if you want to connect them in series, you just bridge directly across. And they didn't do that. They did the fancier thing where you put the batteries in all the same way. But then they're crossed over internally to bridge. Yeah, so those two are bridged together. This one. And there's actually a bridge between these two battery banks on the circuit board. So in fact, if I just go ahead and plug this together into the circuit board, then we should be able to tell which batteries go where. So I'm only going to plug this together enough to get the power in right now. And then if it seems good, we can figure out what to do next with it. Now this power connector and the flat flux are a little bit trying to occupy the same space, but only a little bit. Probably some mechanical reason for that to plug in kind of weirdly like it does. Yeah, they must have to really be careful to get the wires in the right place, because otherwise they'll just get gnashed by the gears in this thing. There's like this whole cable management thing going on in here, which doesn't seem to hold that well after you start taking it apart, but it exists nonetheless. Like there are little molded places for the wires to go that don't quite necessarily hold it, but kind of do. mean, maybe that's why they have all the plastic sheet on the inside so the wires don't abrade up against the inside of the metal case as it turns. That kind of seats back in there. That seems to be down pretty much all the way. So I have not plugged in the speaker or the accelerometer yet. Let's not worry about that yet. And for this, I'm going to maybe tape it to the housing. Just to keep that from flailing around and breaking itself. I'm assuming this is not going to turn, but it turning right now would be annoying. So, I think we saw that this one on top and that one are connected. Or did I get the other way around? Is it this one and that one? Yeah. So this battery compartment is wired in series. Same with that one. Okay, so this, just to get this straight, so this is wired to that. Also, this is wired to that. This and that are wired together. So that leaves this. I should really put some tape on these or something. Just to remind myself which of these are not useful. These are just shorted to each other the way it's wired in the socket. I can easily take this tape off later. It'll just help me avoid making mistakes right now. Okay, so then this is connected where or nothing? Okay, that's the actual negative. That's shorted through. That's the actual positive. Alright. So what do we got here? Power supply off, 6 volts. It's always hard to grab onto the positive lead of a AA holder. This is the style where it's a flat piece of metal that fits into a slot and then has like a little raised bit that holds itself in. Let's see. I think if I hook this under on the top side, it'll make good contact. Alternatively, I could jam something in there or just find that particular positive wire. Oh, can I grab the capacitor? It's a little weird that I can't grab the capacitor, actually. Maybe that's something to do with the 2 series batteries? Like, you don't want the... Yeah, I don't know. I can't quite tell how that's connected. Yeah, I think it is actually easiest to go in on the bottom, as annoying as these are. Unless I want to solder something else to the board, which I'd like to avoid right this minute. I would like to have a fake battery. I should 3D print one of those at some point, just a fake battery that I can put in here. I remember my dad had this camcorder that I guess he wanted to run on AC, and it only took batteries. Of course, custom batteries, because that's what everyone did back then. And I remember him building a thing that looked like a battery out of like mostly wood, and it was fun. That plate with the lights behind it is falling out, like the thing behind it isn't quite seated in all the way. Tuco, what's up? Don't know if that's making good connection, but I'm going to turn on the power and we'll see if it blinks or anything. Yeah, it is. That was the blink. 6 volts, 10 milliamps. Just turn it off and back on. Let's see if we can repro that. Cool. Okay. Well, that's a little precarious, but let's see what we can do with it. Let's make sure that's still powered when I'm not touching it. Maybe not. The positive lead is very tenuous the way I had it connected. Maybe that is too tenuous. Tenuous power connection on a thing you're debugging is never fun. That seems okay so far. It's drawing 10 milliamps. Let's get the magic probe and the laptop hooked up. Was that a cat shadow? Couldn't quite tell. Oh, another cliffhanger moment. All right. So the JTAG adapter we'll be using is this delightful little black magic probe that Peter sent. It's pretty neat so far. The nice thing about it relative to a lot of debug adapters is that it implements the functionality that you would usually find inside a tool like OpenOCD. So you can just connect GDB directly to it, which is pretty awesome. Little ribbon cable. Now let's turn off the power. Got us a little cable there. right, so the first thing we should see is some serial devices. Here's the Blackmagic probe. We should see, yeah, the cu.usb modem. I'm forgetting which of these is which, but one of these is the UART on there that you can use to talk to the target, and one of them is the actual GDB interface. So if we run GDB first of all, it wants the extended remote protocol, and then it also doesn't like tab completion in GDB, or at least this build I have doesn't. Let's see if it's this one. Yep, that's it. And then you can use these monitor commands to talk directly to the debug adapter to do some things that GDB doesn't do natively. So I have to take a quick restroom break, but then let's actually try seeing if we can connect to this thing. Hey, Tuco, are you around? The door's closed. He must be in here. Oh, he was upstairs. Hey, Tuco, why don't you join the stream? You're like, what does that even mean? Hey, cat. I'll be right back, cat. He just wants to hang out in the kitchen. Okay. So we want monitor, SWDP scan. Right now it shouldn't do anything because the target is off. So cool, let's try turning it on. That's a problem. I don't think that's actually the right voltage. Oh, connector is not fully seated on this end. There we go, let's try that. That was not the problem. Is it telling the truth? Let's check with the multimeter. Yeah, 0.8 volts. That is not looking so right. Does that change when we reboot it? Like, do we have a button for that here? I thought I saw a button for that. reset button doesn't seem to be reset buttoning. Let's see if I can hold this on VCC while I power cycle it. Let's at least put the ground over here. .8 volts. Power off, 0 volts. Power on, back to 0.8. That seems like a bad connection. That's anticlimactic. Let's unplug this end just to be sure. Okay, let's power that off. Where did I have a good 3v3 over here, if anywhere? I mean, I think my other reference has been the Pogo debug connector, because that's relatively easy to get to, ish, sort of. I mean, it's not great, but it's like way over here. VCC. And I'm expecting that to be this one. Oh. What else do I have? How about ground? This might just be a very barely bad soldering job. Okay, yeah, let's just take a look at VCC. Maybe that was just the problem. Let's start at... Man, this battery compartment is annoying. I would totally just put some different connectors on here if I had those handy, but I wasn't inclined to necessarily solder a wire just for battery voltage. This is all just a result of my tension between trying to keep this unit relatively unmodified and trying to make it debuggable. If I was just going all out, then sure, I wouldn't worry about trying to keep this in the case, and I would just try to soldering stuff wherever. So... Oh yeah, Piotr's mentioning just for like debugging to try it without the Blackmagic probe, but yeah, that was, it might have been hard to see off the screen, but I had the other end of that ribbon cable unconnected. microscope in focus is like a part-time job. So VCC is that one. Is it that one? No. I think that just was not tinned sufficiently. But let's see if we can reproduce this problem just to be really sure of it with the multimeter here. Measure resistance between VCC over here and then a couple of points. Like, so that should be 0. Yeah, 0.2 basically. It looks like I can also get the wire right here just to test that joint. Is that going to be enough? I can't get a good connection there. Let's make you beep. 0 ohms, okay. I was pretty sure it was at the other end, that just confirms it. Let's pull up that tape instead of trying to go through it. Oh yeah, Kapton sticks to other Kapton really well too. This is also the material that they make, well, not this flat flex, because this flat flex is obviously not heat resistant, but when you do have heat resistant flat flexes, they're usually made of polyimide, which is what Kapton tape is made of. I think this wire was just badly tinned when I attached it. I think that's what's going on. Just gently rubbing it with the soldering iron right near the tip to help loosen any not quite attached insulation or solder on that part of the wire. That says 0 ohms. Let's see if we can get power out of this. I think we still have everything connected. It's a little bit... Let's make sure this gear is not shorting the circuit board. Okay. Power on. Blink. 2 volts? Am I just gonna need to measure resistance here, or why is that 2 volts? Reset, I've got like 2.7 volts. Ugh. I've got a pretty good 3.3 on SWDIO. SWD clock is not super happy. SWD clock is low. We actually want to make sure these debug signals are good. Back to resistance. VCC 0 ohms and 0.2 ohms, 68k ohms, 100k ohms, 300k, yeah, that seems fine. It is kind of instructive seeing the resistance between VCC and all these be kind of different to indicate that they're going places. And it tells you they're not shorted to ground or power or probably to each other. I'm starting to wonder if any of these are shorter to each other. Huh. These are shorted. But it's potentially fine. I don't know, I don't have high confidence in this, but I think we should try attaching the debug adapter again and see if it can talk, and if not, maybe just put it on the O-scope and see what hints that gives us about the signal quality. Because it's not just broken, like, it's powering on and flashing the lights just fine. Powered on, 20 milliamps again, flash again. Let's just see what it looks like on the debug probe. Oh, huh. Maybe with a slash. There we go. Ooh, yeah. Maybe this isn't actually 3.3 volts that I found. Maybe it was something with a weak pull-up. So, I'm also trying to be careful about whether I'm measuring things with this thing in deep sleep or not. So this powers on, it goes to about 10 milliamps. During that bright LED flash, it's like 120 milliamps, and then it goes down to pretty much 0. But let's see if we can find 3.3 volts on this connector. If not, I might just not worry about 3.3 for now and use the Blackmagic probe to power that. Jarrett is asking, what's that distant thunking away? Oh, maybe you were hearing Tuco's litter box routine. Every time Tuco uses the litter box, he likes to scratch at stuff nearby, and that's pretty loud. I wasn't really paying attention though, because I just tuned that out because I'm so used to it. So we get the meter somewhere where we can see it in the camera. Where we can see it without all the glare. Yeah, 0.7 volts here too. But what about some of this other stuff? Like maybe reset, which should be... Okay, ground, clock, reset should be this one. 1.2 volts, what? 1.2 volts. Something seems bad. There's some 3.3. What is that? That's the one right before VCC, I think. That's SWDIO. I guess we could test reset. Like it might be it has a weak pull-up just to... I don't know why we'd be seeing 1.2 volts there. Hey, Tuco. I hear you, Tuco. Yeah, let's try current to ground. And then reset. 0.1 milliamps. I'm not seeing the flash after I take reset away though. Yeah, I guess one thing, so backing up a step, so this is generally trying to add JTAG to the smart lock, which there are a lot of different ways to do it. This particular way, I would like to try to make it relatively easy to use for my coworkers who maybe you just want to plug this into a device, but so on that, to that end, I was trying to make it something that you could attach to the original debug interface on here, so that it would be easy to get it out of this sort of weird mechanical environment. But that is sort of starting to turn into this thing where this is actually turning into, well, this is a little harder than I expected because of maybe the power management system here. At this point, I don't know whether I'm not seeing it, whether I'm not seeing the 3.3 volt because of a power management issue or a just flat out bug that I've introduced. So let's open up the oscilloscope and see what this does during power on. And let's take the Blackmagic probe out of the circuit, just for consistency here. And so the scope I will currently put on VCC. At least what I think is VCC. You still booting, little scope? What are you doing, little guy? Okay, let's watch this thing boot. So trigger on 333. Let's maybe even use roll mode, because this will be pretty slow. What are you doing, Tuco? Horizontal. Is that power line hum? Hey, Tuco, what are you doing? What's up, cat? Can I fuss your face? Cat. Okay, so 0. Let's apply. Oh, it's already powered. Let's power cycle it. This is looking like a bad connection. Oh, weird. I got a little bump there when I turned power off also. Oh, Peter's asking, did I try to connect to the debug port on the older revision of the board that you have nice holes on? I hadn't yet. I was thinking about doing that, but I guess I figured it would be easier just to do most of it on the board that that was like a fresh disassembly, rather than the one that was in kind of pieces in an unknown state from earlier experiments that I wasn't involved in. What else can I do here? Where can I get an actually good 3v3 on this board? Maybe just poking at the that pogo pin thing on the other side. I guess I can kind of see how the developers would have done this. Like, you can kind of get to that pogo pin thing with it sort of disassembled. It's not great, but I could imagine like disassembling it this far, flashing it, then doing whatever you need, and probably not even having to reassemble it. Ground, where are you, ground? Okay, I think I've got the scope grounded all right. I don't know, that should be ground. That's pretty noisy for ground. I'm wondering if I just have a bad ground here. For at least something that's going to work at such low frequencies, maybe I'm just going to alligator clip this to the power supply. Yeah, I mean, if this one's going to be annoying, yeah, and that might be worth switching tactics back to the other one that's already kind of taken apart and easier to fuss around with. I forget who said this. Maybe it was Bunny. Maybe I'm getting that confused with someone else. Somebody gave some pretty good advice for reverse engineering. I think this was Bunny in an Ask Me Anything recently. But they said that if you can, get 3 of the device you're trying to reverse. 1 to kind of keep pristine, 1 to just completely break, and then 1 to do most of your experiments on. And I think that's a great idea. I usually have not had that luxury, but then in hindsight, it's pretty much always what actually ends up being required. Oh, I do have some of these. Tuco, what do you want, little guy? The thing where you tape stuff to alligator clips and then the tape doesn't want to come off cleanly. I just wanted to make sure I had a good ground at DC, which is why I ran an alligator clip to the power supply. Maybe the problem was with the ground, actually. I don't know, that's probably not the only problem. That's supposed to be 3v3, and it's really, really not. Power off. I wonder how much of this is the battery connector. Oh, I think that particular problem might have been the battery connector. Yeah, I really need a better shim for that battery. I think what I want to do there is, like, literally just stick a AA in there. And can I get a AA in just the front battery holder? I just want to put a AA in there and some copper tape. I'm only using the AA as a spacer. The other side of it will not be connected to anything. This is some multi-purpose copper tape where I'm struggling to find the end of the roll. There it is. Oh, maybe that wasn't the end. It was close. Okay, so it'll be kind of like that. And then I want to put this in right there. Let's try that. 6 volts still. Great, 20 milliamps. That should be much better. Now what do we got on this side? ECC. Oh, is that good? Was my problem just bad power the whole time? That is still not good. That's still like a volt. Huh. Yeah, this is not so great. I assume this is just a bad connection somewhere, but it could be a few other things too. But yeah, maybe this is a good time to try the same experiment on the other board. This is interesting though. These two hardware revisions might also have different firmwares if they have different radios. I mean, it's either that or they detect at runtime. Okay, let's at least put this kind of in a pile. And then let's go back to this one. So the story behind this one, it should be pretty much the same. It was bought significantly longer ago, so that would explain it being a different revision. This one, I think one of my coworkers started to analyze it and then didn't really have the right tools handy or something, so it didn't really end up getting much done to it. But it had some stuff soldered to the JTAG, which was not in great condition, so I took it off. But the connectors still, or the, what am I calling them? They're bigger than vias. I guess they're test points, but they're definitely just like holes that people put for soldering wires to, or for maybe test points that like having holes for centering purposes, but is that the horizontal? Yeah. Okay, so also an STM32 here. I think that's flux on the chip rather than something the manufacturer put there. So TMS, TCK, TDI. So if we're going to do serial wire or single wire debug, then, or serial wire debug, I always want to call it single wire, but it's actually 2-wire, and I think it actually is serial wire. So TMS, TCK, reset. That's the same one that we were looking at earlier that doesn't go directly to the chip, but goes to something else that also ends up acting as a reset just fine. I didn't see a labeled 3.3 volt here. The one that I've been assuming is 3.3 volt is pin 1 on J1, which also has the thicker trace there. So we could pull it off like from that via maybe. Hello, train. I had some little wires that I set aside for this earlier on this stream. I think these might be them. We have many separate signals here. 5 pins, really. One more. Ooh, we've got red. Cool. Those are the pins we needed. So I'm just going to kind of haphazardly tin one side of these and then stick them on the board and see if we can talk to it. This will be a little less fancy than what I was trying to do, but probably just fine. red, maybe? Kind of want a little more surface to attach this to, just for mechanical reasons. Oh yeah, and as Piotr's mentioning, this board has the full set, so JTAG, not just single wire debug, serial wire debug. Yeah. I don't know why they did that, but that's the way it is. I mean, I assume we won't need to use those. Maybe they just did for speed or completeness. That is gross. Flux pen to the rescue. Alright, this is going to be really, really temporary. Not the real reset, but at least it's active low. That needs more tinning. I think the other side is the one I tinned, whatever. Also temporary, but fine for now. And then we just need ground. Lots of places to get ground. I think that's where I would usually like to get it. I don't know, that'd be nice to leave those pads untouched if it's convenient. I think the tab on this regulator is also ground. Let's check that. Oh, maybe that's the input or output. Where do I have something I know is ground? Maybe over here by the radio? Yeah, that's ground. That isn't. That is. Okay, that might be a good place to get it. Ah, what a booger. No. dangerous to do this to the capacitor, since any mechanical stress on this wire can really easily damage that capacitor. But temporary. Very, very temporary. I don't think I would ship the board with these attached. Okay. I'm going to get these ready to plug into the Blackmagic probe, but not actually plug them in. So same little adapter here. Ground. Then VCC. This is TCK. Reset. TMS. And I think we just need to hook these up to the power wires again. And then make sure this operates fairly normally. We can try attaching the probe. Alright, 6 volts. 20 milliamps. Now it's asleep. Checking the idle state. BCC is 3.3, TCK is 0, TMS is 3.3, reset is 3.3. Interesting. I think that's fine. I don't think TCK needs a pull-up. Like, it's allowed, but I don't think it's required. Alright, where am I on the other end? Oh, press reset on the adapter, good idea. Yep, that works. Get that on frame, maybe. Yay. Alright. I hear you, Tuco. Alright, let's attach that with the power off, maybe. On. Ooh, right. Okay. That could mean a few different things. So that could mean it doesn't support this device. It could mean that it's locked somehow. It could also mean that it's in JTAG mode instead of SWD, potentially. Although I don't think that's a thing for STM32. I think for STM32 you can always switch between them. Oh yeah, and Piotr says I need a GDB init file. That is true. I would set that up if I was planning on this being stable. Let's at least. So I'm a little concerned by the TCK was not showing a pull-up. So I'm just going to look at these with the scope and make sure it doesn't look like anybody's trying to fight the Blackmagic probe. Oh, where were we? I think we wanted that, but with scope backed on. So Yeah, that's TCK. That's TMS. Oh, is that? Geez, I might just be sampling too slow. Am I not triggering on that? I think the trigger was just at a very different frequency than what I wanted. That's TMS, which seems right. Here's TCK. Seems right. It's strange that it does not detect the target. It looks like it has OTP set to disable it, maybe. Also, you can try JTAG to make sure you have that available. Yeah. Yeah, so I mean, if the chip has a way of disabling JTAG, it's certainly possible they would be using that. Like, they could disable just like readback, I think. Like, you can lock. I'm getting like ARM confused with ARM. I'd have to go back and look at like what specifically is an STM32 thing. But usually there's a way to lock the flash memory, so you just can't do anything with the flash memory except for bulk erase it. But sure, I guess we can try JTAG too. So what else do we need? We need TDO and TDI. That's just 2 more wires. Let's turn off the power. I think I still got the stuff I needed though, because like if I want to talk in this blog post about kind of replicating debug infrastructure, I've got a few different things I can use as an example, even if this didn't turn out to be super fruitful. And then this is certainly a pretty representative setup, and it's looking likely this isn't going to work, but we're going to see. I was going to be really surprised if JTAG was enabled, but this was the thing that I set out to do, so. Hey, Tuco. I think Tuco's found a good spot over here. The vise is on the floor and just where I wanted the camera to be. Hey, cat. Whoa, Emily has a huge USB cable. Well, okay, maybe this is a good chance to catch up with the chat since clearly I'm behind. Hey, Tuke, what are you doing down there? Does STM32 have a partial flash erase bug? That's a good question. Oh, all the Nintendo Switch had the SWD port enabled. That's interesting too. Oh, the gay USB cable. Yeah, I've got one of those too. It came with I got one with my Magewell HDMI grabber, so I have a USB 3 cable with an A on both ends. Yeah, several levels of disable, that sounds right. And yeah, no, I don't think you can do boundary scan over SWD. Yeah, I think I saw something like this in the documentation for Blackmagic Probe also. Yeah, I've heard of that too, but I think that was a long time ago. USB K to K. I mean, I don't know, some people make that joke. Like, to me it seems like a bit of a weak joke, but you could try to make it anyway. Like, I don't know, some people might get offended. I'm not one of those, but I guess I could also see why some people would. Let's see, I think the thing to do is just add those 2 wires. See what we got for colors. So the attack is to take 2 devices, Robert says, and on one device, on device A, you erase the first half of flash, put an op sled, and dump the second half. Do the opposite on device B. Yeah, no, that seems about right. I was hoping to be able to do something similar with the Siemens PLC and this thing that seems to be a bootloader, because if I can get that to partially install my image, then I might be able to do something similar with reading out the parts that haven't been erased. But that really depends on how the bootloader works. Alright, let's tin these while yawning. Power's off. It'd be really unlikely if this one has debug disabled, but the newer model doesn't. That seems like usually not the progression, but possible. Woke. Yeah, that's a little cold. There's also UART. We could look at the UART. It's unlikely to be that interesting. These are huge. Enormous. Usually don't think of solder as being that springy, but it is a little bit soft and springy. Okay, so this one, TDI. This one's TDO. TDM. Alright. No, back to the computer. That one. It only works like the 8th time you press it. I think I'm just ready to turn this on. Blink. Make sure we can reboot it. Wildmania is asking, what is the resolution to this microscope you're using? 1080p. I don't know if that's what you wanted to know, though. The lens, I don't have especially accurate specs on it. I mean, it's like a cheap, it's not quite a USB microscope. It's like a little bit above most USB microscopes. It's an HDMI microscope. But yeah, no, it's a pretty generic HDMI microscope. Like if you just search on eBay, HDMI 1080p microscope, you'll find like 10 of these. And I got mine for $130. It's about the same price on eBay and Amazon. So I'm going to try a couple things. It's running again, I can reset it. I'm going to try scanning JTAG. I'm also going to try scanning JTAG right after rebooting it and see if either of those show me something different. No? So it looks like I'm having trouble scanning in sleep mode, but if I scan while it's awake, I've got this STM32. Can I do that with SWD also? Yeah, interesting. Well, I think we're in the firmware. It looks firmware-y. Oh, good cue from Piotr in chat. Mon set, or no, S reset connect. Did I type that wrong? S reset. I feel like something is making like a clicking noise in this part of the shop. I can't tell whether it's the camera making noises. Oh, it is. The lens. Is that the focus? It must be. I don't see it changing focus, but I hear it. Huh. I guess it could be the stabilization, but... Okay, so mon help. We have STM32 commands. Mon connect SRST enable. Thank you. Great, so now SWDP scan. Let's try from a fresh power on. Did it not flash? I might have just not been looking. So reset. I don't see it flashing now. Am I already connected? Is that the reason it's not flashing? I'm not quite sure what's necessary to actually disconnect this. I'm just going to try, what if I press the button on the Blackmagic probe? And then see if I reset it. No, that's not resetting it either. Maybe if I just reset the Blackmagic probe. Oh, now it's coming out. There's probably something I can do to detach. I just didn't quite know what to do just then. Okay, let's see if this is the right thing. So, yeah, I really do need a GDB init at this point, don't I? Is that still on my clipboard? Yeah. Wait, what do we do? Connect SRST. And yeah, I think that's what we wanted. Let's just make sure that works even when it's definitely gone to sleep. I guess it's already attached at this point. Is there like a detach? It's not just letting it run at this point. Well, I'm not going to worry about that. I'm just going to connect to it and tell it to run and see about that. Oh, I think Piotr is trying to make a point here. History save, target async. Yeah. And he's saying I'm going to want these set mem inaccessible by default off to access my route.io. Yeah, I don't know if I'm going to need that like right now, but I will want that at some point. That does look like a good setup though. What does the target async on do? I also remember I like to set height to 0 in GDB because I don't like the pagination that it does. I'd rather let my terminal handle that. That works. Cool. I forget where the memory is. There we go. Yeah, there's some memory. So it would actually be useful to just dump this all at this point. I feel like there's an easy command for like dumping memory that I'm spacing out in the moment. There's like something for saving memory. And we should also just go ahead and get the memory map for this micro, just so I know exactly where the flash is. So this is which again? F152. Did I already have that up here? Yeah, now I can dump the flash to a file. Yeah. Oh, that's a good picture of Took. Dump file. Yeah, probably. Dump. Oh yeah, dump binary, I think is what I want. Or dump memory. Oh yeah, what does dump binary do? I doubt it knows about the sections at this point. Yeah. Okay, maybe that is what I want, although... What is the difference between dump binary and dump memory? I don't know why this is different. Maybe the default dump format is something not binary, but I don't know why. Oh, Pyotr, you already looked up the sizes and everything. Wait, is that too many zeros? Or am I just not reading this correctly? Yeah, let me get the data sheet up here. I just want that up for reference anyway. And now I just need to read the number of the chip. 52. Oops, that's not what I wanted. Is that saying 64K? $152cc, yeah. Well, let's just grab a little more than 64K and see what that looks like. Something, okay. So 16, or 32K rather, is what we were at too. Oh, is it not going to give me any file because it didn't get the whole range? That's fine. So that stuff at the beginning, I don't know what that is off the top of my head. Then we've got something that looks sparse enough to be like a header or maybe even an interrupt vector table. And then maybe some empty space between like the bootloader and the application, perhaps. Is this really only 32K? Because I thought we were going to have a lot more flash than that. Up to 128K, where I'm looking for the table that tells me. Here we go. Oh, that's not it. There's a table somewhere that's like how big is the flash per part number. There we go. Flash memory size, it's after the C in the part number. Really? STM32. In the way. L152. So low power. 152 means we have an LCD controller. Okay. C is 48 pins. Then this next C is a memory size, which is actually not on this data sheet. So maybe I'm on the wrong data sheet. Okay, well maybe it is pretty low memory. That would be weird. I don't know why they would pick something with so little flash memory. L152CC. Okay, so this, I'm on a different page now that's saying 256K of flash. Maybe that's also just up to. My God, that's RAM. Oh, what I'm dumping. Oh yeah, that makes sense. I guess I'm just forgetting the memory map, which is also another reason to be here. I just wanted to do this in an orderly fashion and look for the chart that's like, here's all the memory sizes, and then go look at where the memory is. Oh, these all have 256K. Okay. Cool. Memory map. Why was I having trouble dumping from 0 before? I think for some reason I'd had like a little brain fart where I thought the flash was at 0 and I thought I tried it and then it didn't work. So I was thinking, oh, maybe I'm remembering the address wrong, but it really should be at 0. And 256 256K and hex. I need to remind myself what that is. 40. 8000. Okay, where are we finding that though? 8. Oh, okay, I missed this part of the data sheet. It's so little. Okay, flash memory, yes, 800. That is maybe flash, but not necessarily. Gotcha. So like that, dump. So flash, 256K. That looks better. Those are definitely flash addresses. So that's our IVT. That looks better, like a firmware image. Page at the end. This looks good. Let's just see if it has any interesting strings just as a first step, but at this point I don't want to steal my coworker's thunder, so I shouldn't do too much with the firmware image. I just wanted to get it out for them to look at. I would like to know why the other one isn't working, like why the new model isn't working. Can we get a real firmware version number for this then? It looks like this is where, what was it? Yeah, this is where we'd expect to find a version number somewhere. Ooh, LED burn-in. I guess they were having problems with that. I mean, that's probably not like screen burn-in, it's probably more like manufacturing burn-in, but still. At this point, I don't want to go too far in here. I'm just looking for a version string to see if I can title this correctly. I could also ask the app what version this is. There's a git hash in here as a 32-bit number for some reason. Yeah, well maybe I won't get the version just yet, and I'll name it based on the revision of the PCB I found it on. Let's take a closer look at this with the power off. Oh. That says 3lock 8. I think that's the version of the PCB, which doesn't necessarily bear much resemblance to the firmware, but it would be good to note what we got this from. Oh, Robert's asking to dump the radio firmware. Yeah, I guess I could. From what I'm seeing, though, it looks like they're treating the radio as a pretty dumb peripheral, and the intelligence seems to be in the STM32 side. But so it's probably a lot more interesting to get the STM32 firmware. Anyway, I guess I will just name this file, and we can do the rest of this. Well, my coworker will take care of the rest of this. So the last thing that I wanted to take care of is to just figure out, well, can I get the other board to this point? Because it looks like that was still just hitting some unrelated electrical problem. Let's just name these files first. So this is 3lock 8. So version unknown, and then flash.bin. So that'll be enough to like be a quick start, but I'm sure if this is actually not unlocked, my coworker is probably going to want to actually connect a debugger to this, so it would be nice to make something a little less temporary than this mess. So let's see if we can do something like that. Oh, that wasn't quite the camera I wanted. So just for a recap, it looks like this is indeed smart enough for both JTAG and single wire or serial wire debugging, at least on this older version of the lock. So now I want to see if I can get a similar setup with the newer version, which should be pretty similar. I just have probably some stupid electrical problem I've created for myself at this point. So, I should probably take these off before I ship this board to anyone, but because it will damage the board more when these have force applied to them, but right now I'm just going to gently set this aside. And back to this lock. So, the first thing is I want to make sure we have a good reliable ground and 3.3 because that's going to make it easier to debug everything else. Hey, Tuco. Oh, you know, I think I have a CC programmer from TI. I didn't use it much because the toolchain was so bad, but I got it because it was cheap. So yeah, I have that. I'm not sure it's quite the most interesting thing, since the other reason I don't want to necessarily go too deep into the CC thing is that this newer version of the lock doesn't even use that chip. So if my coworker was looking for bugs in that firmware, they wouldn't necessarily be that widely applicable, since the manufacturer seems to already be moving off of it. Oh yeah, Peter says that I'm so glad the Blackmagic probe worked, at least for the first board. Yeah, well, I suspect it'll work for the second one once I get the board itself to feel a little less unhappy. I suspect I just have a bad ground here or something like that. Okay, let's back to the somewhat splayed out version of this. In place, and then I just want I hope I wasn't doing something dumb, just like putting the connector on upside down. I don't think I did, but now I'm curious whether that was the thing all along. That is definitely the lens. I'm gonna be noticing that now. Well, let's get the power connected. Well, no, actually I don't want to turn this on yet. Let's just measure resistances, or even conductivity. Buzz this out, as they say. So, probe disconnected. So, ground. Ground should be solidly connected to the battery ground, which is way over there. Let's go ahead and connect that to the spring clip I was using. seems fine. VCC, where do we even get that from? There isn't quite such a giant obvious voltage regulator on this one. But I do have the pogo pin 3v3 labeled. It's also possible the pogo pin connectors on this are different. Oh. Well, that's interesting. Now I'm just not getting continuity to 3v3. Maybe I got some of these backwards. I'm getting continuity between 3v3, or what I thought was 3v3, and TMS now. Maybe this is a problem with the flex connector still. I wonder if I got this pin out wrong. Let's get this under the microscope again. So I think where I've got the right probe again is 3v3. And that's TMS. Let's at least get this in here so the microscope will focus on it. I think the problem is right there on that one that probably looks like it would be a problem. I mean, I keep testing it, but so 3v3. So first we've got ground. That's ground as expected. Now 3v3 on the right hand. That's the one that is labeled on my note as SWDIO, and here I'm getting 3v3. I mean, not as a voltage, as a connection to something else, which I'm assuming is 3v3, so I've got a couple of assumptions. At least one of them is wrong. I'll try to find a better 3v3 reference. Let's look up a pin on the processor. Oh, I thought I already had this open. Oh, I bet it was open on the other computer. I always hit that problem. Pin diagram. All right, this is the right package. LQFP48. Pin 9. Let's look there. That is definitely 3v3. Okay, so my pin counts on the flat flex were off by 1. I think. So that's 3. I need to update my sticky note. That is not the right pin. So 3v3 is that one. Where is actually SWDIO? What is that? Yeah, these are both just off by 1. Okay. Update the sticky note. Move the pins. Maybe it'll work then. I think that's what we want. So something like that. We get a better connection between what we think is 3v3 and maybe what's actually 3v3 now. Yes. And TMS. And TCK. Yes. Great. So here's what we got now. Not that. This one. So we've got our lock. Power is coming in through some clips on the negative spring clip, and I'm going to attach this to this copper strip in just a sec. I guess I can now, the power supply's off anyway. So that's our input power. So then we have the other side of this partially opened up, board hanging out, flat flex attached, card full. Oh, nice picture of Wildmania's cat, Sivka. Is that your cat that recently gave birth to like 6 kittens? Oops. Alright. So, flat flex, cable. Alright. Let's try turning this thing on. So, power attached. Plug this into the probe. And let's just make sure we have this ready. Okay, GTB is not attached yet, but unconnecting it from the previous thing that is no longer there. All right, power on, 6 volts, 20 milliamps, blink, and waiting for it to go to sleep, and it looks less asleep than before. It's 10 milliamps now. Maybe it's powering the level shifters in the Blackmagic probe. Let's see if we can connect to it. That's promising. Sweet. Oh, is there no? Yeah, I don't have that. So, I'd like to do the same dumps. I might just have to remember the addresses. That's fine. This is RAM. '08, and 0800, or sorry, 0840. That's 4 megabytes. That's not 256K. Let's cut that by a 0. Okay. What are we going to call these? So mem.bin, flash.bin. Does this board have any identification? Of course, the number is under the flat flex. This has a completely different board number scheme, even. This one has a part number and is copyright 2015. All right. So I'm just trying to write a note to myself there to say that that's the version of the PCB I got this from, but that I don't actually know what the version of the firmware proper is yet. I assume I will in the near future, or whoever works on this next will. Here's our RAM. I wonder what all that is. I mean, that's some of the RAM. There's going to be more RAM, but... I don't really care that much about the RAM dump. This is what I'm interested in. Looks right. Some toolchain related stuff, maybe? I mean, this might be the firmware version, honestly. Alright, this string. Bat level. Wow, this has way less strings than the old version. Interesting. These two seem like very different pieces of hardware. Like, potentially significant redesign happened. But I'd be surprised if there wasn't still a lot of overlap in the software, at least. Oh, yeah. Also, as Dr. Toon mentions, that like if there's firmware update support, which I think that part of the reason why my coworkers were interested in this was that it doesn't necessarily have publicly visible firmware update support. But yeah, if it does have firmware update support, then that is going to be, the keys for that are almost certainly going to be in these binaries. Robert's asking to dump the Broadcom/Cypress firmware just because, as far as I can tell, the pins for that are not broken out on this circuit board. So, like that's in ROM. Like, to do that, I would just put one of these Bluetooth chips on a board and break it out. But I'm not really that interested in doing that right now. That doesn't seem like it's especially related to this project, and that would be a completely different thing to start down. Well, I think maybe the only thing left to do is to try to put this back together, and then to make sure we can still access the debug port. Let's see if we can do that. Oh, I like Wildmania's cat pictures. Add another bit of Kapton to the back of this just because it would be nice. Alright. Now this stuff is going to be heavy and fragile. So, LED diffuser goes in, and then we've got to make sure these wires end up in roughly the right spot. Well, there are like 8,000 incorrect ways to put that piece in. That's better. So that goes kind of like this. Seems roughly right. So this circuit board isn't really held in there that much. It's just kind of, so the motor housing is bolted in. The LED board that this is soldered to is below that. I don't know what keeps the board from rubbing up against the gear. Luck, maybe? I don't know. Maybe put the screws in before I fuss with the wires endlessly. I'm just trying to make sure none of the wires are pinched before I tighten the screws, because that's a good way to destroy wires. Alright. So now, find all the screws. These three. This is the one I magnetized. It's big. That's better. There's a strong magnet in this motor. I'm really surprised they didn't turn off firmware readout. Maybe they don't have anything to hide. That'd be nice. All right. Now, let's finagle the wires into approximately the right location. It's really hard to imagine how this stays together just in normal operation, much less how they put it together in the factory. But a lot of things are complicated. It just does not look inexpensive. All right, 2 battery connections. Got that. So we've got these screws, we've got a bunch of mechanical bits. Accelerometer. This does look like it's designed to mostly go back together with that flat flex in place. I'm not really going to be able to put it through a hole in the back panel, so maybe I just cut a really wide slot that fits that entire board and then tape the board to the back. So this is definitely a place where it is possible to put this together incorrectly, and I'm probably going to do so. So this is the, oh, stop wobbling. This piece mates with the, I guess I'm going to call this a clutch, the clutch piece on the motor. And then there's a spline that fits into this plastic gear, but there are a lot of different ways for that to go on. So yeah, so that's their mechanism that lets you rotate it somewhat. So it's like left, right. I don't know how much this matters. I'm going to try to put it kind of in the middle. And then, oh, maybe actually I should put that kind of in the middle and then put the accelerometer kind of in the middle and hope that those are the right 2 things to do together. Oh, I see. So I should be able to, how does that not just pull the accelerometer apart? I guess I don't quite understand that, because this is, the end stops on this change as the motor turns. Oh, Peter says, is that a torque limiter? That's what has the teeth. Oh, can I get this to slip? Not easily. It doesn't feel like it's designed to slip. It looks like a spline. It might be a torque limiter. It really doesn't seem like it's designed to slip, though. Yeah, that's interesting. Yeah, maybe, I mean, maybe it is a torque limiter just for much more torque than is easy to apply right in this configuration. And if that's the case, then that would, this whole design would make a little more sense, and maybe it could sort of, like maybe it's designed so that sometimes the motor needs to overpower the torque limiter. I don't know. It does seem like I should be careful about this accelerometer not pulling itself apart. I'm really not quite sure how it manages not to destroy the accelerometer. Unless maybe some of those extra chips on this board were another accelerometer and it's comparing the two gravity vectors to each other. That still seems really sketchy. So maybe the thing to do is to try, just in case there's a reason to set this so I'm not pulling the accelerometer apart, let's position this so it's all the way counterclockwise, and then maybe put this in such that the cable still has room, like there-ish maybe. Yeah, I don't know. I'm very unconfident about how that's all put together. Pardon me. Alright, I don't know if this is going to work, but I think maybe it's designed to wrap a little bit more. Something like that. Let's see if that survives. So then gears, both of these need a shaft. Then, so this gear goes like that, and I think that gear goes like that. No. Man, so there are probably ways to assemble this where it's like initially kind of okay, and then it just destroys itself by ripping this flex cable apart. This is such a weird design. So I think I need to turn this a few more clicks this way. Well, at least it's got room now. These gears are really eager to slip. I'm just trying to figure out if there's anything else I need to do mechanically before putting the cover on so that it doesn't destroy itself. Okay, well, I'm going to assume that's probably fine for now. Let's try to figure out how to put the back cover on. front cover. Looks like that. I might also just see if it's possible to power this thing directly over the 3v3 if you don't end up wanting the motor. I don't know. It's probably fine to power it over the batteries. I'm just not quite sure what my coworkers are going to want to do. I always have this problem when I'm preparing for like somebody else's hardware experiment, because everyone has such unique ways of doing hardware experiments. Well, I think we just want to go through there. So something wide enough to just stick that whole board through, which means thinking maybe just cutting a slot right below this ridge. Let's warm up the soldering iron. Excuse me. Where is that tool? It's in here. Oh, it is not in the place it usually is. I mean, I was looking for a particular soldering iron that has a nice flat wide tip that's actually intended for this, but I could also just put an old tip in my WAS51 and use that. Maybe that's what I have to do. Alright, so crude hot knife for cutting plastic using a soldering iron tip that you otherwise don't care much about in a room with plenty of ventilation. I think both of these are pretty old. Let's just use this one. That. Let's bring the fan over here. Out of the shot, just barely. Alright, so looks like we have a lot of room there. I'm just going to make a slot that's wide enough for one of these circuit boards to go through. I'm actually getting pretty much none of the fumes up here, so either it's just not as stinky as it seems like it should be, or the fan's working pretty well. Probably the latter. I'm going to try to get as much of that off in the brass sponge as possible. Alright, there's my hole. Let's maybe try to clean this soldering iron off a little more. This tip is not especially great, but it'll be alright. I mean, as alright as it ever was in the recent past. See if that fits. I wonder if this is what they do to the production models too when they need to debug them. So, I think we're done with that. So now, speaker connector. And then maybe I turn this on and see if, like, I don't even know how to do these, but I guess you can connect to them with your phone or something. See if that all works. Like that. And then this can go potentially like that, so it doesn't block anything important, but it's still accessible. Let's go ahead and put these in, why not? I mean, there are some reasons why not, but I'm feeling lucky, I guess. I have no reason to feel lucky, but so be it. That's the one with the sticker residue on it. I don't know where that one goes. I think they're all the same anyway. It's just that that one has the sticker residue on it. Yeah, as Robert says, oh, the smell of cancer. Yeah, I would not do anything like that in a really small space. The shop here is super drafty. I can also put it there, but I mean, that might not be the worst place for it. Just didn't entirely want to block this thing that you can use to see where the motor's pointing, but yeah, let's put some double-sided tape and mount it where the serial number is. That'll be plenty good enough for our purposes here, I hope. So that is normally the side of this that points toward the door, and this is normally the front. little bit assembled weird. And we could try just putting the original batteries back in. Should be one more battery. Somewhere there exists an additional triple or double A for this. There it is. Seems all right. So many, like every single one of these pieces, there's a bunch of incorrect ways to assemble it. Same here. I mean, maybe that's not supposed to be incorrect, but it feels incorrect. It doesn't open as well. Huh. It's a weird design. Let's see what we can do with this probe. Let's see if we can still connect. Let's take the O-scope down. Hey, train. There's our chippy. Cool. We got our stuff. I guess we can't reboot like that. Huh. Where that happened. I can single step. If I can. Oh! That is probably it going to sleep. If I press the reset button. Come on, button. Ifconfig. Alright, well, I don't think that's a problem with my debug adapter. So it's attaching just fine. I think when I continue, it's just going to sleep and losing the connection. One way to solve that would be to find out where it's going to sleep and set a breakpoint there. But I'm not going to go too far down this. I just want to make sure the hardware is working. And it looks like the hardware is working. one thing I might do is try to just try to use this thing normally just a little bit. I mean, that's fine. So, I guess I could try doing the thing with the phone. Like, assume there's just an app I download and then it connects to this over Bluetooth. Is my phone completely out of battery? Well, maybe that's a sign that this has been a long stream and I should probably wrap it up right here, because my phone is completely out of battery. But, oh man, I still kind of want to see what happens. I want to wrap this up, so let me get a battery pack for my phone. I'll try this. Okay, my phone is like completely out of battery. Well, maybe that is a sign, because it's not going to turn on until I at least charge it a little bit. So, I think it's probably fine. I would like to test this and watch it actually connect to the app just to make sure I haven't broken it, but it seems like things are probably in good condition. So this means I have one which is pretty easy to connect to, so long as, like, I'll just make sure to give them this pin out, but maybe they want to connect to it with Blackmagic Probe anyway, because this is kind of handy. Yeah. I would like to connect to it, but my phone is not happy. So I have to use the restroom. Maybe I'll just give you a cam for a minute or so, but if I come back and the phone will boot, we'll try it. If not, I'll end the stream. Tuco, you're so bad at staying in the chair when I get up to use the restroom. I guess my phone is back, though. Meow. Tuco, I hear you, little guy. Sorry for the flashing. This HDMI switch always does that. Is that the one? That's the one. Cool. Load, load, load. Tuco, where are you, little cat? Hey, Took. Meow. 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 Go installer. Man, installers. We've been doing this thing where humans build computer software for a long time, and installers still get stuck at 100%. Can I get the DSLR on here too? Slightly less wide. Come on in. Wait, simpler and more secure. Those are the two things they chose? I feel like those two things are obvious lies. Alright. Come on in. I don't want an account. Oh man, I'm not going to create an account right now. Fuck you. Well, maybe we'll do this slightly differently. Because I don't want to make an account right now. Let's just see if it shows up. Yeah, Max says, I don't think I've ever had a simple experience setting up IoT devices at first. That's part of the problem. Like, in general, people don't know how to build them so that they're both simple and actually secure. And even making them simple at all is hard. Somebody's got an HTC phone. I wonder what that is. Oh, or maybe that's a Vive. I'm also not sure what you have to do to get this into advertisement mode. I mean, I kind of assume it would have to advertise pretty regularly. But it's possible they just didn't include any strings, so it's hard to tell what it is without the strings. How far can I get with fake data in the August app if I just don't want it to actually care who I am? First name. So secure. Okay, I guess that's where we get stuck. So you cannot use this piece of hardware unless they have your phone number and email and all that. That seems completely useless to me. At least unless you're willing to hack it up to pieces. And if I knew what to look for, I could probably just see if it was advertising a Bluetooth device, but I don't really know what to look for right now. But Robert says, I'm surprised your employer doesn't have a shit phone that has all the random IoT installed and all the accounts created. Well, that might be a thing we do eventually, but like, I don't know, I've got some stuff like that for my own stuff, but that's not something they have right now. Anyway, so I might have to go through there and, because like, I mean, I do have a phone that I use for like random hacking around, but I don't really want to give the number for that on the stream right now. All right, well, I may or may not care about testing this later. I'm leaning toward not. I think the hardware's probably fine. I'll probably just throw it in a box and send it to my coworker and make a blog post, and this will be fine. So I think we're done. I think we have everything we need. We've got the firmware, we've got debug access. We've got a vague idea of how this weird piece of hardware kind of operates, and I think I managed to put it back together without breaking it. And I think Tuco wants attention. Wow, what do you want, little guy? You brought me a bolt. You brought me a bolt. What do you know? Do you want to play? Wow, yeah, you know, guess what? Good job, Tukester. Man, having a lock that doesn't work unless you give it your phone number is kind of a weird thing. Like, I don't think I'd buy one of those. Good job, Chico. Where'd that one go? He likes taking the bolt and putting it in a giant pile of additional mess, so it's like he likes hiding the bolt for me or something. Thanks, Wildmania immortalized my tongue forever. Oh no. No, that was supposed to be a bad picture, don't use it. Hey Chico, where'd the bolt go? I just missed where you dropped it. Is it behind you? Where'd it go, little guy? Here it is. Maybe I should have like a poll at the end of every stream, like, on a scale of pineapple to socks, how smart do you think this device was? Good job, boy. He's getting something out from underneath the bathroom scale. There must be all these little human scale objects that are just so weird to interact with as a cat, but then he's gotten used to them over time. Good job, Tuco. Good job, boy. Oh, a question from Robert in the chat. I missed if you entered this earlier, but which DSLR are you using? It is the Canon, I want to say it's, I keep forgetting how to describe it because it's got two different model numbers, but I think the model number that's actually on the front is the T5i. Yeah, the Rebel T5i. But then if you actually look in G-Photo, it's got a different model number. Smart like molding bread. That sounds about right. Wow. My other monitor, now that I disconnected the phone, is advertising stuff at me because it's an Apple TV. And usually it's full of movies that I've never heard of, but I guess I still managed to not see the new Star Wars movie somehow. And now they're advertising it on the Apple TV store. Some people said it was good, but I also have trouble caring about Star Wars now that they've just continued making, you know, it's like not even, like I don't know why I would care about it just as a thing and as a brand new movie. Well, sure, but there's a lot of new movies come out that I have a hard time caring about. You got it, boy? Tuco, you're so good at this. I'm really glad the Blackmagic probe worked out for this, and I've so far, like, I just got it. It's pretty new for me, but it's been really nice so far. And now I'm eager to do more stuff with GDB, like scripting and GDB Python, and curious how fast it is for that. I've still got the cat following camera on my mind. I'm sure I'll be working on that as soon as I have some time. Now I'm imagining when we're following Tuco around playing fetch, I can imagine having like a mini map overlay that shows like a thermal vision camera from the very top of the shop so that you can kind of see, here's where the robot is, here's me, here's the cat. Oh, waving back to Morix in chat. Hello. Yeah, no, I definitely, like, I think the Blackmagic probe looks really nice. Like, the hardware is really well designed, and I really appreciate how easy the software is to use. And, yeah, overall, it just really seems like a really nice niche in the design space. I also really appreciate how, so there are at least two things about it so far that were just like, oh man, I totally didn't even expect that, but it's so useful. The built-in UART and the target power on and off are both super handy. Like, I haven't even used either very much, but just seeing that they're there and thinking about how I would have needed both of those in previous projects puts a smile on my face. Oh, I should probably get some sleep soon. Do some more work tomorrow, do taxes at some point. But I was working on them over the weekend. I managed to find a bunch of the paperwork and then do a bunch of unrelated tidying up. But I still have a little bit of work to do in actually like filing them, so. Anyway, I bet Tuco and I could play this all night. Where is it, little guy? You find it? Good job. You're so good at that. Oh, Robert mentions that the pick kit has UART and target power too. I don't think I've ever used the pick kit. I used to be really into picks, but I had a Pick Start Plus, which had a big 40-pin ZIF connector on it. Good job, boy. Oh, Peter's wishing me good luck for the taxes. Yeah, thanks, I appreciate it. It should be pretty easy. I think the hardest part was going to be finding the paperwork, and I think I did that yesterday. Now I just need to actually set aside some time for this. Time management during the weeks has been difficult since I feel like there's always, you know, the part of the day when I'm trying to get stuff set up and like come up with a plan for streaming and kind of prepare for that, and then there's the actual stream, and then there's the like aftermath, and I feel like it's been really difficult to balance all of those different sections lately. But again, something I hope to find a better solution for soon. It's T5i. Yeah, that's right. The camera is a T5i. I also think they have different names. I forget how much it was when I bought it. I think it was like $500 or $600 when I bought it. I bought it in a kit that also included this lens, though, so I forget how much of that was the camera and how much was the lens. And yeah, as I mentioned before, I've tried Magic Lantern on it, but it was all right. it didn't seem to give me the features that I really would have wanted, like clean HDMI output, and it still seemed to be kind of buggy, and I lost a card full of video due to it, and then I went back to the regular firmware. So that's my experience with Magic Lantern so far. It seems nice, but so far it hasn't actually been that useful. Ooh, Pietro's hinting about maybe a variable power supply option for a pro version of the Blackmagic Pro. That sounds nice. That could be useful for certain devices. Hey Tuco, are you tired? Is it time to end the stream? Is that what you're saying? Do you want one more bolt? Are you just always into more bolts? Tuco? Yeah, I think that's a yes. Yeah, I didn't buy this camera specifically for streaming. I think if you were buying a camera for streaming, I wouldn't necessarily recommend this one, mostly because of the clean HDMI. Like, I got it for pretty much general purpose use. For just like studio streaming use like this, I would really prefer something with an external recorder, since it's really nice just to send all the video to a computer with a NAS instead of having to shuffle cards around. So, oh yeah, Piotr says good SLR for video is very difficult to find. Yeah, and I've heard people, you know, with specific model recommendations, which I think I'm going to flub up if I try to mention them off the top of my head, but there are particular Canon cameras that I remember being pretty common for like professional video, but they're more expensive ones than this. I think this was one of the mid-range cameras, and those are a lot pricier. Oh yeah, the 5D Mark III is probably what I'm thinking of. Yeah, the 5D series is, if I remember right, something that they use a lot for video, and it's also, I think, a lot more expensive than this one. But I've been thinking about upgrading the main camera for this stream. I mean, it produces pretty good video on the SD card, so when I edit stuff together after the fact, it usually ends up looking pretty good, at least for 1080p video. It would be nice to get clean video out. You know, as charming as the Servo AF is, like, it would be nice to get higher resolution. Yeah, that would be great. Piotr's one of his other projects is this open source cinema camera, and yeah, I could imagine a lower spec version of that being really nice for streaming, because a lot of the problems right now are just that the consumer cameras that are popular just don't quite do the right things. It's not really an issue of the, you know, the physics or the raw money costs necessary to accomplish the stuff. It's just market size and that kind of thing, at least the way I understand it. I think Tuca's pretty relaxed. I think that's looking pretty good. I think I might want to try being kind of relaxed like that upstairs. Oh, that's cool. Dr. Toon mentions, in passing, the thing that changed my life most recently was getting a bunch of magnetic tool holder strips and putting them everywhere to have tools always within reach and handy. That sounds really nice. I could imagine putting those along the desk here. I've been getting a lot of mileage out of sticking magnets on the back of like remote controls and dongles and various things, and just sticking them to the light stands around here. But having some magnetic strips along the sides of the desk would be really nice. I should probably look for that. That's a really good idea. Oh, okay, Piotr clarifies that the Axiom camera isn't his project. He's just a fan. Okay, I misunderstood. Oh, another good Tuco screen cap from Wildmania. Oh, and then Robert says, IMHO, a lot of both consumer and professional video equipment doesn't really do the right thing. Oh yeah, earlier they were having kind of a protracted problem with this AverMedia dongle, which I've never tried the AverMedia stuff, but I've had similar problems with other video capture dongles where like it doesn't quite work at the mode you need, and the software is super unreliable and only works in Windows, and you know, all those things. Are you ready for more fetching, Tuco? Whoa, this one went over here. That was a mistake. I know, I'll try it again. Oh, Piotr says you'll need a demagnetizer for your tweezers. That thing that I was using to magnetize the screwdriver earlier today also has a demagnetizer, so maybe I'll end up using that more. may need to buy a degausser. Yeah. Hey, Tuco. I love how he just kind of like rubs up against your leg when he's interested. Hey, oh, sorry about the flashing. Maybe I've got another bad coax on this rig. I am looking forward to replacing this. But it would also be nice to debug it sometimes. Oh no. Dr. Toon's tweezers are magnetized. Yeah, sorry about the flickering. I re-terminated one of the coax cables, and I think that's probably still holding up all right, but there are like several coaxes that might be flaky here. Like, maybe it's that one. Yeah, I think it's this one. Which one does that go to? This is like a little coax patch cable too. This isn't even like a cable I would expect to have issues. Hey Tuco. Is that any better? I just reseated the connector a little bit. No, not really. Huh. Okay, I was about to start seriously debugging this on the bench, but maybe that's not the thing to do when it's already this late. Alright. Hey Tuco, you want any more fetching, or are you done tonight? Where's your bolt, honey? This cat just always wants more. Sodium says the Axiom camera stuff looks pretty shiny, but it's also really expensive. Yeah, I feel that way about some of the Blackmagic stuff too. Like, their cameras look really nice. If I just wasn't at all concerned about cost, I would probably get one of the Blackmagic cameras to replace this DSLR. Yeah, more to-go cameras. Yeah. Well, I guess that's the question. Like, you know, would I still need multiple cameras once I have the one that flies around on wires? If so, do I need them all coming in simultaneously, or do I just need a SDI switcher to select between them? Good job, Tuco. Yeah, I see that. Blem. Good photos of Tuke. Thanks, thanks, Wildmania. I could probably throw this bolt all day for Tuco. You got it, Tuke? This might be a tough one. This might have gone under the fridge. Yeah, open source is definitely not necessarily the fastest way to get something out to market, but then once it's there, like, it's a lot more durable. It's so easy for companies to disappear. Got it, Tuco? Did that one legit actually go behind the fridge? I'm sorry, Tuke. We'll find more. Oh, hey, buddy. No? You don't want to be picked up? That's cool. You want another bolt? You want me to help you get that one out from behind the fridge? Is that a pulley? Is there a pulley behind the fridge too? I don't know. Alright, I think this is the wrap-up point. I can't find the bolt, and I think Tuco's mostly done playing, so I think we'll call it a night. So, try to get to the camera so I can say goodbye. Alright, thanks for watching, everyone. Happy hacking, and I'll see you next time. And, and if you're interested in these streams in the future, if you're catching this later on the archive and you want to find these in real time, then I announce these on Twitter. If you go to, so these Senrio streams, if you go to Twitter, Senrio Labs is the account, both on Twitter and on Twitch. And if you follow that there, you'll get the live streams, and you'll get announcements whenever they're happening. So have a good night, everyone. I will see you next time.